Am I audible? Dr. Lam sir, hello. Dr. Fencom Lam, am I audible to you? Hello. Dr. Lam sir, hello Dr. Lam. Dr. Lam sir, did you connect to audio? Sir, Dr. Sainakam Lam, sir, please share your screen. Hello? Sir, please share your screen, sir. Is it shared? Sir, please connect to audio, sir.
Sir. Sir. Sir. Yeah. I, షేర్ స్క్రీన్ చేయమని చెప్పండి సార్ ఒకసారి.
Yeah.
షూర్ సార్ షూర్ నేను ఇచ్చేస్తాను ఒకసారి. Sorry for interruption, sir. Your screen is visible, but you're not connected to audio. So, if possible, can you open WebEx once? So, can you open WebEx once? Once you just open your WebEx, you can check the audio settings.
actually.
Sir, am I audible?
Can you hear me?
Very good morning, sir. Am I audible, sir?
Yeah, thank you.
Hello.
I should share my file here on mobile.
Sir, am I audible?
You will share my file or I will do it myself.
Sir, am I audible?
Sir, your voice is very low. Can you increase the volume?
Yeah.
Sir, you are able to hear very meager voice, sir. Please just raise the volume.
Yeah, put it this box. So now. Yes, sir. Yeah, sure. Sure, sure. So, Ronnie? So I will share my video. Yeah, I use my. Yeah, I think microphone is okay. So did it show slide? I will show for myself. I think it's maximum. I will try to speak louder. It's okay. Hello, can you share my
Perfect, sir.
presentation?
It's very perfect, sir. Perfect.
Perfect. You are able to hear. Yeah.
Very good morning, sir. It is perfectly audible.
Yeah.
Hello.
Yeah, sure.
Yeah. Sir, can you share your presentation like in WhatsApp so that I'll share your PDF. That will be very
Yeah,
helpful.
sure.
My warm wishes to all the erudite audience here. I am Dr. Eman Nasingrao, working as professor in the Department of Computer Science and Engineering, Pune Lakshmaya Education Foundation. We have here Dr. Sainak Kong Lam, and it is my privilege to introduce him as a keynote speaker for the second day of the International Conference on Intelligent and Smart Computing and Data Analytics. Dr. Sainak Kong Lam received the Bachelor of Electronics in Telecommunication Honors and Master of Electronics Engineering in 2010 and 2012, respectively, from the University of Engineering and Technology, Vietnam National University. He obtained his PhD degree from University of Technology, Sydney, Australia. His research interests focus on modeling, performance analysis, and optimization for 4G and 5G technologies, stochastic geometry for model for wireless communications, artificial intelligence for wireless communications, network security, network communication, radio and cellular communication. He is currently working as a lecturer in the Faculty of Electronics and Telecommunication Department of Vietnam National University, Hanoi. This keynote address is for actually 45 minutes, followed by the question and answer session for 15 minutes. As it is online mode, the participants can post the questions in question and answer session in WebEx. Now I request Dr. Saine Kong Lam, sir, to start the session, please. Sir, thank you. Please start the
Yes,
session,
sir.
sir.
Thank you, the chairman. So,
Thank you, sir. Thank you.
yeah, I would like to thank you, the
Hello?
conference organizer.
Yeah, sir, you are audible, sir. You can start speaking.
Yeah, sure. I will change. So thank you, the professor, for inviting me, so I can have a present opportunity to talk today. Especially Professor Kora Bahu Prakash. I'm sorry if I spell your name is not correct. So let me check. I will send the technical the presenter. My presentation. So we can start now.
Dr. Saine Kong Lam, sir. Hello?
Yeah, sure.
Sir, could you please
Have you
send
received
your PPT
my?
so that we'll be able to share? Could you please send us the PPT so that we are able to share?
Yeah.
Yeah, please
I'm
send the
sending now.
PPT through WhatsApp or by mail or whatever it is, so that we are
Yeah.
able to share your PPT.
Yeah. I'm sending now. Maybe. Okay, I'm sending. Have you received?
Sir, your PPT received. Am I audible to you? Sir?
No, I send you file. So
Yeah. We have received your PPT. We are able to share your PPT, sir. Sir, there is a request from our end. Could you please wind up the session around 10:05, 10:10 like that?
So
Hello?
do you prefer PPP file?
Yeah. We have received the PPT, sir.
Yeah. Can you show?
So could you please wind up the session by 10:05, 10:10 like that, so that will because there is another session followed by it.
Oh, so okay. So it's no
Yeah.
problem.
So yeah.
So can you send me a schedule again?
Yeah. 1 minute, sir. We'll be able to share your screen. Don't worry. We'll be able to show your PPT.
Yeah, sure.
Yeah.
Thank you, sir.
Sir, you can start the session, please, sir.
Sure. Thank you, Professor. I'm sorry for the
Sir, you can
delay.
start the session. Yeah.
So my talk today is about the deep learning algorithm for future neural network. So here's a brief overview of myself. I'm currently a lecturer at the Vietnam National University. I graduate. I obtained my PhD from University of Technology, Sydney. So
So could you
my
please increase the volume, sir, please? Could you
Yeah,
please
so-
increase the volume?
my main research is about 4G or 5G or future cellular network, particularly inter-cell interference management. So my research methods based on two techniques is about the mathematical approach and simulation approach. So for mathematical, I use some stochastic geometry model to model the cellular network and analyze and do some performance analysis. And for simulations, I do some model and simulations the cellular network and then create some new algorithms. So next slide. Can you go next slide? Sorry. Can you move to next slide? So here's the main content of my presentation. The first is about some highlight point about the future wireless network communications. And then the model for the wireless model use machine learning, particularly deep learning, for single input and single output for CMOS system. And second for multi-antenna system, and the third for multi-user system. And the last one, I will give some research challenges at this time. So let's move to the next part. The future, some highlight point of future wireless communications. Okay, here's an overview of the cellular system from 1G to 6G. As we know, the telecommunications start from 1980s, and that's for voice communications. And after 10 years to 2019 and 2010, 2020, move from the feature phone that just send text message and voice and no data data. Until 2000, we have access internet with higher speed via some smartphone, high data rate smartphone. In 2010, we have a very smartphone, some very power and strong phone. And now we are currently in 2010. We have 5G system. 5G system supports very high data rate and a huge amount of connections. Now we may direct to 6G in next few years. So for next slide, we see the future wireless communications. We will compare about the next slide, sir. Here's a comparison between 5G and 6G. For the 5G, we have also about the big data rate that 20 gigabit per second for maybe for cell, but for 6G, maybe up to 1,000. And the connection density from 4G, from 5G is just about 1,000, 1 million connection per kilometer square. But for 6G, it should be 10 millions connection per kilometer square. So the number of devices connected to the network increased by 10 times from 5G to 6G. It's a lot of technology, a lot of scheme will be used. And to support a lot of collections, many work focus on using machine learning to do work with a lot of collection. There's some point we see why we need machine learning or similar techniques to do with future wireless communication. Because wireless communication includes modeling the channel. The channel is random available. The wireless channel from user to the base station are randomly, and the location of user are also random available. And the interference that's called the use of two subchannels at the same time and at two base stations. So here interference is also random available. The traffic, of course, is a random available because it depends on the user service, the number of users, and the change the symbol and bit on over the internet. Of course, it's also random. Wireless security still random variable. So to design and implementation of conventional communication system are built up on strong probabilistic analytic model and assumptions. Many assumptions are random variable. So we must deal with many random variable parameters. But the existing communication theory is strongly limitation are in utilizing spectrum because spectrum resources is limited and many devices try to connect to the internet and try to explore the spectrum of spectrum resource. So there are many problems. And one thing is handling the complexity of optimization for wireless applications. There are many applications. The number of users is 10 million. So 10 million people may be connected to the network together. And each user may be required different service. So it must optimize for all users. And currently, some connective radio system can optimize their spectrum by themselves. They can detect, they can classify, they detect the signal, detect the device, detect the user, and classification of user and classification of service. And it can predict, which can predict task. So it's similar to operation of deep learning. So many people think that the cognitive radio system should be based on deep learning technique. So that's why we use machine learning, particularly deep learning, for future wireless communications. If we see, the machine learning has many benefits to adapt with the change of future wireless communication. The first thing, the machine learning can automatically extract a high level of feature from the data. The many different users will have different type of data, and some data from particular user can have a similar information. It means it's highly correlations. So machine learning can extract some feature from the data, and it's capable of handling a large amount of data. Yeah, it's some benefit of machine learning. And many data from the user is not labeled. So the machine learning have a type we call unsupervised machine learning can handle that problem. And one is very strong point of wireless communication is all the device connected to the wireless system, and they can share their knowledge. Knowledge means their data, their behavior. So the machine learning can collect all information together and to process. So this means the machine learning has many benefits to use in the future wireless communications. So and machine learning may be used to design. On the next slide, let's see. So you can design the physical layout. The physical layout based on machine learning or spectrum utilization. Many users can try to access the user. So access the frequency resource. So it must be utilized. And wireless security is always from 2G, 3G, 4, 5, 6. Security always big problem of any network. So let's see the conventional system block of wireless transmission. We have some bit, some user transmit some bit and source informations. All the bit transmitted by user we call source informations. And the bit, the data will be encoded by the encoder and maybe use the channel encoder. After encoder, they use modulations and push and transmit the modulated data on the channel, wireless channel. And in the receiver detects the signal and combine with channel estimation to demulate the received signal. Check, we check, move to channel decoder, source decoder. And finally, we receive the signal and we detect the transmitted bit. Sometimes there is error, as you can see in the figure. We transmit bit 1, but then we detect the bit 0. Then it's error. And the purpose of most of the wireless communication technique is improve the accuracy of transmission or reduce the probability of errors. So let's move to how to model the single antenna system using machine learning. Let's consider the very simple model. This slide, you see, we have one source and one receiver. You do know that S is the signal of the transmitter and S hat is the signal of the receiver. We assume that the transmitter want to communicate one out of m possible messages. It means it can transmit one of m possible to receiver. A receiver must to detect correctly which is transmitted at the transmitter. And the transmitter applies some modulations to convert the message to the symbol and to some modulation, as we know, PBSK, QAM, or QAM64. So the next slide, we can see some example of PBSK, UPSK, 16 QAM. Yeah. For theoretically, we assume that the antenna will transmit an energy constraint. If you see in the next slide, and the power and the amplitude should be constrained. So most next slide, sir. Next slide, sir. So the data rate, one of important is we try to increase the data rate of transmission. So it means we assume that we have transmit k bit, and we just have k information bits, but we transmit n number output bit because there's some additional bit for collection code or for synonyms. So that's why we notice that NK is mean the communication system send one up to power K message through the N channel use. And as a receiver, the receive based on the probability, the conditional probability. It's with the condition is when we receive the receive signal is Y, and we try to detect what is transmitted. It's totally based on the stochastic model.
So Dr. Lang, sir, Dr.
Yep.
Lam, sir, so could you please conclude the session? The other presenter is ready to give the presentation.
Okay,
Could
so
you- so I'm really grateful to you, sir, for your time spent here, for giving the presentation, for your thought-provoking lecture also. We enjoyed a lot. And we got some questions also, sir, in YouTube. We'll be able to post those questions to you later for the solutions to those questions. Okay, sir.
yes.
Could you please conclude the session so that we'll be able to provide the session to the new
So,
person?
yeah,
Yeah.
yes. I will conclude in yeah.
Yeah.
Give me 2 minutes to conclude, myself.
Yeah, please conclude, sir. Yeah, yeah.
Yeah.
Thank you.
So for deep learning for wireless future wireless communication, we see some research challenges because we see that the mobile phone is very simple. The base station may be simple, but the machine learning require a lot of training sample. So we must to reduce the training sample. And one technique is use support vector machine. It's based on supervised machine techniques. So you can see the figure. And another challenge is we need to do some performance analysis in real wireless channel because the real wireless channel have different characteristics, maybe it's different performance. So we need to investigate. And we need to compare the performance comparison with modern coding techniques such as LDPC or connected multipoints. And we also do some situations such as the imperfect channel. So imperfect channel is very big problems. And the complexity, we try to reduce the complexity of the machine learning and how to make it more practical in mobile system. So that is 5 challenges for communication system. And currently we still develop how to make the machine learning is more suitable for device, for mobile device, or Node B or G Node B. So finally, my talk is about the feasibility of the machine learning for future wireless communications. And I think I addressed some research challenges, how to apply deep learning on wireless communication system. So I think I finished my presentation.
Sir, thank you for your thought-provoking lecture, sir. Thank you very much. And we got some questions also from YouTube. We'll be able to collect those questions and post it to you, sir.
Yes,
Thank you,
sir.
sir. Thank you very much. Thank you very much
Thank you,
for,
sir.
for your valuable times here. Okay.
Thank you. Sorry, very sorry for problem.
No problem, sir. No problem. No problem. We could manage the things. Don't worry.
Thank you, sir.
Thank you, sir. Thank you.
సార్ అసలు మళ్ళీ 10కి పెట్టడం ఏంటి సార్? ఎవరు సార్ డ్రా చేసి కొంపలు మునిగిపోతాయి 10 ఇప్పుడు ఈ 9 to 10 ఇది పెట్టినప్పుడు 10:30 schedule చేయొచ్చు కదా సార్. మ్యామ్ ఆ లింక్ ని క్లిక్ చేసిన తర్వాత పాస్వర్డ్ ఇవ్వడమే కదా.
పాస్వర్డ్ ఏంటి?
మ్యామ్ సేమ్ పాస్వర్డ్ మ్యామ్, KLF CSC OCT
KLEF CSC
OCT.
OCT.
మ్యామ్ మీరే PPT మీరే షేర్ చేయాలి, ఓకేనా?
అవునా? ఓకే.
నేను ఆల్రెడీ స్క్రీన్ పెట్టేసి ఉంచాను. జాయిన్ అయ్యారుగా మీరు? మీరు వన్స్ జాయిన్ అయిన తర్వాత నాకు సిగ్నల్ ఇవ్వండి, నేను మిమ్మల్ని ప్యానలిస్ట్ చేస్తాను.
ఓకే ఓకే.
లైన్ లోనే ఉండండి మ్యామ్, కాల్ లోనే ఉంటాను.
KLEF CSC IoT
OCT మ్యామ్, నిన్న సేమ్ పాస్వర్డ్ నిన్న పెట్టాం కదా.
అది ఆటోమేటిక్ గా తీసుకుంది. ఇవాళ చూస్తా. ఓకే, లాగిన్ అయింది.
1 minute మ్యామ్, లైన్ లోనే ఉండండి. నేను ఈ లోపు పోస్ట్ Vijayashree madam, am I audible?
Yeah, audible, Surya.
Good morning, boss. Once we are done with your introduction, then I'll give you presenter access.
Yeah, thank you.
Thank you so much.
Very good morning to all. I'm Dr. Vijayashree, Associate Professor from the Department of Computer Science and Engineering, KLES. It's my great privilege to introduce an eminent personality today, Anindya Bose, Senior Publishing Editor, Springer Nature. He is part of Global Acquisition Team at Springer Nature, and he is responsible in order to take up acquisition of scientific content in interdisciplinary applied sciences. Nearly more than 26 years of industry experience in marketing and different fields of publishing he has, and masters in organic chemistry from Delhi University and masters in marketing research from Symbiosis Institute of Management Studies, Pune. He took up many reputed talks. He delivered more than 140 invited talks He published ethics in reputed universities, international conferences, and author workshops. He published books for secondary level in chemistry and is a member of American Chemical Society, USA. The majority of his responsibilities include publication of scientific books in the field of applied sciences, including the topics of interdisciplinary applied sciences, computational intelligence, intelligent computing, communication systems, and security, energy, and water services. His portfolio includes monographs, edited volumes, professional books, textbooks, atlases, and conference proceedings. Dear participants, if you are interested in any of this, you feel free to write to him so that we can have his help in all these publishing details. His book series include Services and Business Processing Reengineering, Studies in Rhythm Engineering, and Springer Tracks in Nature-Inspired Computing, Algorithms for Intelligent Systems, Advances in Sustainable Sciences and Technology, Springer Tracks in Human-Centered Computing, Smart Innovation Systems and Technologies. With this brief profile, I would like to introduce Anindya Bose sir to take up his keynote lecture on elements of book publishing. Sir, we are delighted to have your presence over here. And before you start your presentation, all the management of KL University and the complete organizing committee would like to thank you for providing your acceptance to make all our publications into Springer, and we expect to continue with your support all through. Thank you very much, sir, and we welcome you to take up the session now.
Thank you. Thank you, Vijay ma'am. Just share the screen. I hope you can see my screen right now, correct?
Yes, sir. Thank you very much, sir. Yes, sir. It's visible.
Thank you. Thank you. Thank you, Vijay ma'am. Thank you, ISCDA and KL University. It's a great pleasure to be here on this Monday morning, auspicious morning, and conference. And as about my profile and my work areas, I will be talking more about the publishing of books over here, how you can actually get into different steps and what are the different steps which are there and what are the different types of books, how they differ from each other, so that you have a practical idea about them, so that you will be easily able to understand what kind of a book you want to write and what exactly you can work, how you can work with publishers. So that will give you some kind of an idea. So hopefully it will be useful. Let's start with it. See, first I would like to greet you with Happy World Teachers Day. I don't know how many of you are aware of this, because we celebrate Teachers Day on 5th of September, but UNESCO celebrates International Teachers Day on 5th October every year. So today is a World Teachers Day, and teachers are someone who are facing a huge and a steep challenge during this pandemic, because this is a period when everybody is facing a lot of challenges, and especially the challenge which teachers are facing is basically the communication over online classes. So a couple of months back, I was actually giving a presentation about what are the challenges of COVID, and I came across this particular terminology which came to my mind at that point of time, that COVID is something which COVID-19 is a disease which is hit the whole world, and it's a pandemic. You all are aware, we are in the middle of it right now, and we are facing many steep challenges. But there is one challenge, it is the challenges of online virtual interaction and discourse. This is a challenge which is faced by mostly by teachers, the faculties, how you can actually overcome online virtual interaction and discourse, how you can do it. So this is opening a lot of doors to discovery, and this is a different kind of a COVID. So I fully salute the teachers who are doing their best to make things possible, because it is not easy to take classes, take examination, do admissions in these period. This is a very, very tough time for students also. And as you can see in a conference, which we usually are accustomed with, we go to a conference, we interact with people, we talk to people, we attend sessions, and physically we meet people so that networking flows. That is very, very different right now. We have to come over online mode, and we are just talking to our own laptops, and we are not able to interact face to face. We are not able to see I cannot see your faces. So that is a dilemma, because when I go to conference, and I really love to go to conferences, I love to talk to people, interact with them, so that they have a lot of queries related to publishing areas, and I really sit with them in physical mode, and we discuss many things. But unfortunately, that is not possible in a situation like this. So with the dedication to all the teachers, this particular presentation I will give. So once again, happy World Teachers Day. And let us start the presentation. The presentation, it starts with, I come from a company called Springer. So it is obvious that I should tell you something about Springer before I go to the topic. So this is the company which started in 1842, almost 178 years ago in Berlin. In Berlin, Julius Springer, you can see the photograph of Julius Springer over here. Julius Springer started this small bookshop in Berlin. And during those days, the conferences were very different. Publishing was very different. People used to publish their own work. Scientists used to publish their own work. There was self-publishing was very dominant. And people used to come to these shops, and people used to buy books. So it came to Julius Springer's mind, why not talk to these people? There are many Nobel laureates who were visiting his shop. So they can actually work with me, and we can start with something called publishing of scientific content. So this is something which started in 1842. It took almost 80 years. In 1924, we shifted to another location. We started with another location in Vienna, just after the First World War. Then after the Second World War, we started our Heidelberg office, which is the biggest publishing office of Springer. And we, right now, our editorial head office is Heidelberg, which is like having more than 500 people sitting over there. In 2015, Springer actually had a small joint collaboration, you would say. It's a joint venture sort of thing with Nature Publishing Group and Macmillan Science and Education. So the name of Springer has changed. You will see many places now it is written as Springer Nature. Many people, they come to me and ask me why the name is Springer Nature, because it's in 2015. We started a new company where Springer and Macmillan Science and Education came together. Now we have 10,000 plus colleagues, and our offices are in 50 different countries. So this is about Springer. So what exactly we are doing in Springer in the books area, because we publish books, we publish journals, and we also do school books. That is the Macmillan Science and Education, they are doing it. We are doing magazines, like we have Nature and we have Scientific American. There are many others. And what exactly we are doing in books, I will tell you. And this is and we will talk about elements of book publishing today. Springer Nature's role in academic book publishing, because we are into academic book publishing. We are not publishing anything non-academic over here. So we are completely into academic areas. So Springer is largest academic book publisher in the world. As you know, there are many publishers, good publishers are there, and they are also publishing many books like Elsevier, Wiley, TNF, Sage. But Springer is the largest book publisher in the world, and our expertise lies in books. Books all across research areas, like we publish books in science, we publish books in technology, medicine, and in recent years, in last 20 years or so, we have ventured out in humanities and social sciences. And in 2015, we had a collaboration with Palgrave. Palgrave is basically another company which is basically dealing in humanities and social sciences, a big name. People who are from social sciences, they know it very well. So we cover all areas of research in our book portfolio. We publish almost 13,000 new books each year, which is a very, very big number. That means we are almost publishing 40 books per day. And then there are more than 3 lakh books are available on our platform. We have here, I would like to tell you an important thing, that we have 2 main websites. One is Springer.com, where you will find all the information about our products, about the books, about the journals. And we have another platform which is called SpringerLink.com. SpringerLink is the content platform where the content is available. Springer.com is where the information is available, and Springer Link is the, so if you have to access the book, you have to go to Springer Link, and you can see there are more than 3 lakh books available there, which are available in online mode. It's like ebooks are available. So, and we are the pioneers in digital book publishing, and that is one of the reasons that we are doing okay during this pandemic period. Also, we are able to cater to the science community during this pandemic, because we have started digitizing content long back. We started digitizing content in 1995 with our all journals getting digitized. From 2005 onwards, we have started with ebooks also. And right now, as I said, there are more than 3 lakh ebooks are available on our platform. So this has really helped. Being a pioneer in digital book publishing has really helped to cater the community during this particular situation. So these are the highlights of what exactly we are doing in books. Now we will enter the area of my presentation. Why publish a book? What is the need for publishing a book? Important things first. First thing is that you conduct research yourself, and when you conduct the research, you do it for yourself. There is an aim in your mind. You try to work on those aims with your experiments and methods, and you try to find results. This is what you usually do when you do a research. So you are doing the research for yourself. You are not doing the research. It's always good to say that I'm doing things for community, mankind, and all. These are all big things, and we usually talk about them. But the most important thing is why I do research. It's basically to satisfy my own queries. There are certain questions which are in my mind which I want to satisfy, and in that way, by doing that, I am actually helping others also. So you conduct research for yourself, but you write and publish for others to read. When you publish, that is the most important thing when you are doing about your research, because when you are doing your research is limited to yourself. But when you write it, when you put it in the form of black and white, then the research is actually moving from your desk to the desk of other people. People can read about your research. People who are doing similar kind of research, they can actually get benefited. They can read your research the way you can actually get benefited by reading others' research. So basically what is happening, when you write and publish, you publish for others. You help the community here. When you do research, then you are doing it for yourself. So it is very important that you write a book, you write because when you write journal articles are small articles which are published, and a very small part of your work is basically getting published. Very well, when you are doing PhD, then definitely you are not publishing the whole content which you have done in your research work. It's a very small part which you are basically extracting, and you creating a paper and you are sending it to conference or a journal for publishing it. But usually when you collect all those things which you have done, that's a good amount of work. That is possible only when you publish a book. Now, why you need to publish a book? You need to publish a book to connect with the community. That is very, very important, because networking is the most important thing in today's world. If you see in today's world, all these ranking systems, even for the universities and institutions, are based on the number of collaborations they have, not the quality of faculty or not the quality of students. It is like how many collaborations, international collaborations or joint ventures you have. So connectivity with the community is very important. When you connect with the community, then your work, actually the quality of your work improves. You build your reputation. When you publish a book, your reputation is increased. And finally, it accelerates your career. Everybody is basically doing a job. We complete our PhD, then we look for a job. So for acceleration to that career, acceleration to the job, you need to have some kind of support, and this support is basically provided by your publishing record. And publishing record means either you publish in journal or you publish in book. So these are the 3 things which are very important, and these are the benefits of book publishing: that you connect with the community, it builds your reputation, and it accelerates your career. When you have to publish a book, when you want to publish a book, you want to go ahead and see, okay, I have some kind of an idea and I want to publish a book. So these are the 5 questions which you should actually ask yourself. These are very important questions which you should ask yourself before even thinking about writing a book or submitting a book. What is the first question? What does your book add to the existing literature? We know there is a huge literature available in your area of study. Like if we talk about artificial intelligence, now everybody is talking about artificial intelligence in last 10 years or so, because data is abundance, data is available in abundance right now. But artificial intelligence has not started 10 years ago. Artificial intelligence was started 60 years ago in 1960s. Then it was coined. The term was coined in 1960s. So the literature is available for 60 years. But are you adding anything to this literature? Any value addition you are going to do? That is the first question you should ask. What does your book add to the existing literature? Second question, why are you the right person to write this? Why you are the right person? Are you doing something unique? Are you doing something which will help the community? So why you are the right person? Third question, who are you right? You need to understand the readership very correctly. People who are going to read your book. When you actually target your book correctly to the correct segment of people, then only your book will be able to travel. Fourth question, where will your book be used? Who are the people? First the target. Now where is it going to be used? And fifth question is, how are you going to get your book out there? How you are going to publish your book with a good publisher so that it is disseminated well, so that it reaches the reader, so that it reaches the community. So these are the basic 5 questions you should ask yourself: what, why, who, where, how, and understand why you need to write a book and why you actually are the right person to write this book for the community. There are 5 steps for writing a book, and from starting from scratch to the dissemination part. I will talk about these 5 steps to you so that you understand what are these 5 steps. The first step, everything starts with an idea. You have a good idea, it comes to your mind. My whole emphasis to put this point over here to tell you, when you have a good idea, write it down. Because hundreds of ideas, they come to your mind and they just vanishes. You will find you will have so many ideas coming to you, but they don't remain there. Another split of a second, there's another new idea, then another idea. So these ideas, they come and go. When you have a good idea, a very good idea which you think can materialize into a content, please write it down. So what exactly you are doing when you have a good idea, then you can write something new for future readers. When you have an unique idea is little different from a good idea. A good idea is something which you can give you an idea to do something, but a unique something which fills the gap in current literature. That means the literature which I talked about, artificial intelligence, for 60 years there is current literature available for artificial intelligence, but there are definite gaps. When you have a unique idea, this unique idea will help you to fill that gap. When you have an idea and that idea needs to be formalized into a proposal. First, you have an idea. Now, idea needs to be turned into a proposal. Then only, you can send it to the publisher or you can show it to someone so that they can get that idea. They can understand that idea. Now, how you can formalize into a proposal, how this proposal is formed. There are certain things which are very important for creating a proposal. The first thing is your CV. Your CV is like your biodata and your of publication. This is the first thing a publisher looks for, because they need to understand what kind of publishing you have already done, what all things you are publishing. Maybe you haven't published any book yet, but you are doing a lot of publishing in journals. So they need to see what kind of publishing background you have, what is the history of your publication. Second is synopsis of the book. Synopsis of the book is very, very important. Now, I would like to tell you that 90% people write synopsis wrong. They don't write it correctly, because whenever they want to write, like I was just hearing a presentation before me on machine learning. Suppose I talk about machine learning. You have a book on machine learning applications. correct? Now, when you have a book on machine learning applications, I want to know what all applications you are basically going to talk in your book. The reader who is actually looking at the synopsis should understand what exactly you are going to write in the book. But usually 90% people write a full literature of machine learning in the synopsis. See, I don't want to know what exactly is machine learning. I don't want to know what subject machine learning is going to do. I want to know what is the synopsis of your book, because there are hundreds and thousands of books in machine learning. But on machine learning application, the book which you are writing, what is that, what you are going to present in your book? So synopsis is about the book in 150 to 200 words, which talks about the features of the books, benefits for the readers. So be very mindful that when you write synopsis, write about the book. Then comes table of contents. Table of contents is the structure of the book. This is very, very important again, because if you are creating the structure correctly, then it is very easy for the publisher and the reviewer to understand your book. See, many people again confuses table of contents with index. Index is something which is a collection of words, important words used in your book and present in the back matter. Table of contents is the structure of the book which comes in the front matter of your book. So table of contents is very important. A detailed table of contents gives a very clear picture about your book. Then comes sample chapters. Sample chapters are the chapters which are written for this particular book. Here also some people get confused and they give the sample of previous work to show that they have already published. No, I am not talking about samples of previous work. I need sample chapter of your present work, the proposed work which you are creating the proposal for. When you have all these four things ready, then the proposal is ready and you can send the proposal to the publisher. Third step is evaluation of the proposal. The proposal you have created, you have all the data has been formalized and you are sending it to the publisher. Now the third step starts. Here I have to evaluate the proposal. First, as an editor of the publishing company, I will look at all the parameters. Then I will send it for peer reviewing. Peer reviewing is an integral process and it's done for everything. All good publishers do peer review for books as well as journal articles. Peer reviewing is something where your book will be sent to the expert in that area and they will check or he will put his comments. Now the proposal evaluation is done through peer reviewing. Once the peer review is done and they said, okay, it is okay to go, the book is fine, they have tell you about some revisions, you have accepted, then comes the acceptance and contracting. Contracting is nothing but the legal formality that says, okay, this book will be published by this publisher and these are the people who will be authors or the editors of the book. So there is a document which has been created. Once this document is created, then we come to author package. Author package is something once the contract is signed, the project management team or the production team approaches the author or the editor and they share all the guidelines, the instructions, templates, copyright forms, permission forms. These are all the things which are part of the author package which is received by the author so that they can work on the package, work on the book, and finally they can create a manuscript. Once the manuscript is ready, then the next step is you submit this manuscript to the publisher. The first thing publisher does with the manuscript is analysis of the manuscript. We analyze the manuscript and we see, okay, the manuscript is good to go. There is no plagiarism in this. There is no language issues in this. There is no ethical problem in this. So these are the different steps which is checked between in the analysis stages. After the analysis is done, your manuscript is moved to the next level. Here you can see the second level, which is here, which is like a tagging is done. So the electronic tagging is done. So that means the XML file has been created, because the manuscript which you have submitted will be published in multiple formats. All good publishers nowadays, they are publishing the book in multiple formats. Multiple format means they publish it in print format, they publish it in digital format. Even digital formats are different for different gadgets. Like for iPad, you have an EPUB style. For Kindle, we have a PRC style. For small smartphones, there are different styles for different smartphones. So when we say the book, the manuscript has been changed from manuscript to a book, that means book is available in different formats, that is the print format as well as digital format. And digital format is basically, I said, different gadgets can open that format. So once the book is ready, it is ready in physical state, that is in print format and digital format. The important thing is the fifth step, that is how it can be shared with the world, how the book can be disseminated. Now for dissemination purpose in Springer, what we have a multiple type of dissemination, which I will just tell you. Like first is Springer.com. Springer.com, I said, this is the website which gives you all the information about the book. So we have a dedicated web page for each book. We have sales information available there. We have all the data of the editor, author, ISBN, series number, everything is present over there in Springer.com. So one can go to Springer.com and check all these data and they can find, okay, these are the details which are available about the book. Then we have the content platform. As I said before, Springer Link. Springer Link is the content platform where the content is available. Now we have 10,000 plus institutions are members of this content platform. So the book which is published by Springer is basically going to these all 10,000. It is an opportunity for all these 10,000 plus institutions to see the book. And if they want, they can subscribe the book, or they can buy the book, or they can actually download the book. Then there is a third-party distribution. Third-party distribution, we have distribution through Amazon, iTunes, Flipkart, Barnes and Nobles. There are many marketing channels through which we are distributing this book. So once the book is available on Springer.com, that means when the manuscript is basically submitted, immediately the homepage has been created. Once the book is published, then content is available on Springer Link. The distribution is done through many channels. And finally, we have an author support system, which actually helps the authors very much, because we create covers, we create flyers. You know, these flyers are easily and freely available on the homepage of the book, so that you can digitally download these flyers and you can send it across to anyone digitally also, or you can take a printout and send it. Then we have a lot of newsletters, and these newsletters are basically going to the community. And suppose you have written a book in computational intelligence, so your book newsletter going to computational intelligence will carry all the details of your book. So these newsletters to the communities are very helpful way of dissemination of your work. So we talked about 5 steps over here, starting from idea. First thing which comes to your mind, you write it down, change it to proposal. From proposal, it has gone for checking, peer review, and finally the manuscript is being ready. Fourth, the production is done, XML is created, and finally the book is published in print and digital format. And finally, we have the dissemination of the book, which is going to the reader, which is the whole objective. Now we will talk about types of books and services. Now these are the types of books which are basically different types you need to know. During my citation, during my, initially Dr. Vijaya talked about the kind of books I deal with. So we will talk about them over here. What are the differences and what all these book types are. First is a monograph. Monograph is a scholarly book or a treatise, we say, on a single subject or a group of related subjects. It's basically a scholarly book, a research topic written by single author or multiple 2 or 3 authors. So monograph is a scholarly book on a single subject area. Then we come to edited volume or edited book. Edited book is a contributed volume. This is an invited work, which is very different from monograph. Monograph is written by authors. Edited book is compiled by editors, the person who can invite, who can conceptualize, who can go out and invite contributors to write for that book. Now here I would like to emphasize, and I would like to tell you that if you are a young author and if you are a young research scholar or a young faculty, then you should actually think about writing a monograph rather than writing an edited volume. It works like this. When you write a journal articles, young research scholars, they should concentrate, focus on writing original papers rather than review articles. Review articles should be written by people who are 20 years experience in the industry, in the community, and they have abundant knowledge and experience to review something and write about it. Similarly, editing is also similar note. When you have very good experience on the subject, when you have the capacity to edit others' work, then you should write edited books. Now, the problem in today's world is everybody go for easy solutions. People think that edited book is an easy thing, easy to write, because you collect chapters from people, go for publish an open book for chapters, and just go ahead and this is not the way to write an edited book. Edited book has to be conceptualized very, very well. Then you have to invite people, invite contributors, work on with them, check their work, get the work reviewed by external people. So it is a huge amount of work, and your understanding plays a very big role. So my whole idea is that when you are a young boy, when you are a young research scholar, young faculty, focus on writing a monograph rather than edited volumes. Senior people who have 20 years of experience, they should actually write edited books. Third is proceedings. Proceedings is collection of academic papers. Like if this is a conference we are into, and you can see you have submitted your papers. If the papers are collected by giving you some kind of call, and these papers will be published as proceedings. So collection of academic papers which are coming from conference, congress. So here there is a call for paper, but edited books, please don't go for call for chapters. That is not the correct way of getting chapters. Invite people in your community to write about the work in edited books. Then we have professional books. These are written by industry people. Basically, manual guidebooks like compendiums. These are written by professionals with academic background. And at times they are very, very useful for people who are into academics also, because professional books are more practical oriented books, more technology oriented books. Then we have textbook. All know textbook is a course book, is a formal manual or instruction. It is based on certain syllabus of a school, college, or university. So textbook is a different sort of a book. Although Springer, they don't claim to be a textbook publisher, but we publish in a way more textbooks than any textbook publisher because our numbers are very high. As I said before, we publish 13,000 books every year, and almost 5% books, 5 to 7% books are textbooks. Reference work is a single or multi-volume reference work. Usually they are multi-volume. They are encyclopedias, starting from very basic to the advanced level it goes. And this is a book which can be referred again and again. That is why it is called a reference book or a reference work. Handbooks are very similar to reference books, but usually they are single volume, a single volume book of some 1500 pages, which is again talking about compilation of all key information on a particular research topic. Then we have another type of book, which is Springer Briefs. Springer Briefs is only published by Springer. I will just briefly tell you about this brief. This is like, small book of 55 to 125 pages. Why we have developed this book? Because we have seen that many authors, they write small books, like 80 pages, 100 pages. Now it is very difficult to put this 80 pages work as an article, journal article. It is not possible. Journal articles are maximum 20 odd pages, not more than that. And you cannot accommodate 80 pages over there. And 80 pages of book is again a problem, because when we talk about a monograph, it should be at least 250 pages. So, it's difficult for us to accommodate. So we started with these small books where it is 55 to 125 pages. It is a soft cover binding. Copyright remains with author, which is like very, very important, because we always felt if somebody is doing some work and they want to publish it quickly, because this has a very quick turnaround. If they want to publish it quickly, so copyright should remain with them, and you have the scope of going back and extracting some work from this and publish it in separate journal article or somewhere else. So copyright remains with you. So this is a very nice way of writing a book. Who has not written a book, and they have the opportunity to write a small books to start with, so that they get an idea how to write a bigger book. And sometimes, you have something very small available to you, a work of maybe 100 pages, so you can write Springer Briefs. There is another type of book which is there, which we started very recently, and we have around 165 only available at this point of time. We started with medicine and computer science. Now we are coming to engineering and business management area also. This is Springer Nature Video. these are called video books. Springer Nature video is a half-an-hour video or a 45-minute video on a particular topic. If you really want to know about this, you can go to Springer link, go down below, you can see the link of videos, you can go to video, you can see all these 165 videos available. Few of them are freely available, some of them you have to subscribe. So, this is a book which is like, 30 minutes video on a particular topic, maybe a particular topic like feature selection. So on feature selection, you have 30 minutes, 5 chapters, 6 minutes each. So there is a video. Now there are many videos which are available on many platforms. Like the most common platform is YouTube. But what we have seen, that it is very difficult for people to go for specific research-oriented videos on YouTube, and they don't study over there. But if you have this video available on Springer, which is a research publisher, then the data is more authentic and data is more research-oriented. So we started with this new concept, and we have very few right now with us available. So, but definitely this is growing up, and we are catching with many young people, because young faculties, as I said, young faculties, young research scholars, they love to study from videos, and that is why they love to write also. They love to do these videos with us. There is another mode of publication which is like open access. Open access is a author pay model. So you need to understand this, that something which is open for everyone, we cannot sell that, correct? So that is why someone has to pay for that. So open access is an author pay model. Now author cannot pay this much amount. So that is why we have funders and sponsors. So there is a page on Springer.com, which is like OA funding. You can go to that page and you can say there are 200 funders available worldwide who are actually interested to fund many works. You can get in touch with them, and if your work is of quality, then they will be able to get connected with you. There's a possibility they can get connected, and their work can be funded by them. Why open access? You can see the graphics over here in this particular slide. Open access books are 7 times more downloaded, 50% more cited, and 10 times more mentioned. So that is why when the work is more downloaded, the citation or the opportunity to get citation increases. So that is why it is very important that we see if there is a possibility. If you have fund, then why not go for an open access book? This is the OA funding page, which I was talking about. It is like in springernature.com/in/open research. If you go to this page, you will find there are many OA funding support groups are available. You can read about them, you can understand about them, you can apply with them for OA funding. There is a page for book authors and editors. If you go to Springer.com, under Springer.com, there is a link called services. Under services, you will find authors. In authors, there are journal authors and book authors. So if you go to book authors, you will find all these details are available over there, like resources and guidelines, author services, contact a publisher and editor, then book author help desk. All these things are available. These resources and guidelines are very important. Author services are like almost 90% services are free services which are available, and they are very, very useful for researchers like you who can go and take advantage of them. Then we have something which I wanted to tell you about, ORCID IDs. These ORCID is nothing but like Aadhaar card for researchers. If you don't have an ORCID ID, please go to ORCID site and register yourself. ORCID ID is a unique ID which will be given to you so that your name will not get confused with a similar name like yours, and you will always get correct citation and citation allocated to your name correctly, to your ID correctly. So if you don't have an ORCID, please go and register. This is a free registration, and many journals and books are making this mandatory for the researchers. Before I conclude my presentation, I will tell you about 3 books which are very, very important, 3 or 4 books rather, on 3 topics. First is like how to write and publish a scientific paper. This is written by Robert A. Day. He is considered as father of scientific writing. He traveled in US for 25 years and going to different institutions and telling them how to write. This is a book which is not very costly. This is the 8th edition, and I think 6th edition is freely available on net. If you can go and you can download it also freely. This is a book should be read by each and every person who is into scientific research. Then there is a book called Getting It Published, which is written by William Germano. William Germano is himself, he was a publisher, and this is talking about getting it published is like talking about all the nuances of publication. So all the nuances, this is a very, very good book, which will talk about the patent, which will talk about the copyright, which will talk about fees, what is the difference between ISBN and ISSN. So all small things which there are queries in your mind. And these are the two books which can be referred again and again. You know, they are not the one-time read kind of a book. If you have any question in your mind which is coming up, you can go back and you can refer this book again. There are two more books which I would like to highlight. One is Textbook of Research Ethics, which is written by Sana Lu. This is a textbook which is used by many institutions. And this is a very, very good book on theory and practice of research ethics. One should read this. And there is another book which is written recently, by 2 years ago, by Dipankar Dev, Rajiv Dey, and Valentina Balas on engineering research methodology. So if you are basically in research, you should be aware of research methodology and what are the engineering research methodology. A practical insight is given in this particular book. So before I say thank you to you guys for giving me this opportunity, I would like to say work sincerely, focus on quality, say no to academic corruption. You know, all kind of corruptions are there, and there are a lot of academic corruptions surrounding us. And if we really want to stay happy, stay away from these academic corruptions. Thank you very much for patiently hearing me. This is my email ID, onindo.bose@springernature.com. If you have any queries right now, we can take up. You can ask me the questions if you have anything. But if you have a question later, usually when you go back, you look at things, you try to browse things in what I said in our website, then you come up with many different queries. You can write to me on onindo.bose@springernature.com. I will be very happy to address them. Thank you. Thank you very much.
Any queries from audience, you can please post it in the question and answer box.
If you have any questions, you can write to me or you can even ask right now also. I don't think there is any query, Vijay ma'am.
If any of you would like to interact with sir, you please raise your hand so that you can be unmuted.
If you have any publishing query also, you can ask me. Not necessarily that it has to be related to your books only. If you have any publishing query, anything comes to your mind, you can ask.
Yeah, Asdat sir is waiting. You please give him access.
Some serious winning.
4, 2, 6, 4, 10, 12, 2, 7.
हाँ गलत कर रहा था अभी हम बता दो
यहाँ पे कटकुट
I think we can call it a day, ma'am. I don't think
Yeah.
there is any query. Yeah.
Sir, we'll come back to you. We'll consolidate all the queries and we'll
Yeah,
get back
yeah.
to you through mails. Thank you very much once again, and we are very much thankful to you for providing this Springer publication opportunity for all the participants who are taking part in the conference proceedings.
Thank you.
इतना जल्दी कैसे हो रहा है? अच्छा, ऊपर वाला
I request all the participants to join again at 11:30 for the next keynote session. Thank you all.
Good morning, sir. Ramani Kannan, sir. Sir.
Yeah, good morning. How are you?
Sir, I am fine, sir. I am Dr. Prashant, sir, Professor of Computer Science and Engineering.
Oh, very nice. Nice to hear from you.
Sir, nice to meet you, sir. We'll start the presentation after your introduction, sir.
Okay, no problem.
Yeah, we will start your introduction at 11:30 a.m. sharp.
Okay.
Once we finish your introduction, then you can start your presentations.
Okay, thank you.
Thank you, sir. Thank you, sir. Good morning to all dear participants. I welcome you all to to this wonderful international conference, and it's my immense pleasure to invite Dr. Ramani Kannan sir to give his valuable speech on this occasion. So let me take the privilege of giving introduction of Dr. Ramani Kannan sir. Dr. Ramani Kannan is a senior lecturer in University Technology, Petronas, Malaysia. He received his Bachelor of Engineering degree from Bharatiyar University, India. Later, he completed his Master of Engineering and PhD in Power Electronics and Drives from Anna University, respectively. He holds more than 120 publications in reputed international and national journals and also conferences. He is a character engineer, United Kingdom, active senior member in IEEE USA, and members of IEI Kingdom and ISTE India, and Institute of Advanced Engineering and Sciences. Dr. Ramani is recognized with many awards, including Career Award for Young Teacher from AICTE during 2012, Young Scientist Award in Power Electronics and Drives 2015, Highest Research Publication Award in the year 2017, Award for Outstanding Performance, Service and Dedication in the year 2019 at UTP Malaysia, and Outstanding Researcher Award in UTP Quality Day 2019. Best Presenter Award, IEEE Conference 2019, International Conference at Indonesia. He is actively serves as Secretary, IEEE Power Electronics Society Malaysia since 2020. He is the Editor-in-Chief for the Journal of Asian Scientific Research from 2011 to 2018 and Regional Editor for International Journal of Computer-Aided Engineering and Technology, InterScience Publisher, United Kingdom from 2015. Associate Editor in IEEE Access Journal since 2018. Is also Associate Editor, Advanced Material Science and Technology Journal since 2020. Dr. Ramani is servicing many guest editors such as Elsevier Journal, InterScience Journals, IGI Global, CRC, Taylor and Francis, etc., including Beetham Science and IJPAM, etc. His research interest involves in power electronics, inverters, modeling of induction motors, artificial intelligence, machine learning, and optimization techniques. Now, with that, we come to the end of his wonderful resume and introduction. So I invite Professor Ramani Kannan to start his wonderful speech. Sir, we welcome you to the conference, sir. Thank you.
Thank you so much, Dr. Prashant. You are giving a wonderful introduction about me. Okay, is it audible?
Yes, sir. You are audible, sir.
Okay, thank you.
Yeah, please.
Okay, so first of all, I would like to thank for the opportunity provided from our Dr. Kola Banu, Professor Computer Science and KL University. We have a good relation since around more than 5 years. We have some association research collaboration with us. Okay. First of all, I would like to thank as well as welcome all the participants for our keynote address today. Okay, so can I share the slides? Can you see my slides? Dr. Prasad? Can you see my slides? Desktop? Oh, no.
Sorry
Okay.
for interruption, sir. We are not able to see it.
Can you see now?
Yeah, it's visible, sir.
Okay, thank you, thank you.
Yeah.
So you are allotted only the 1 hours, okay? So now we will discuss about our today keynote speaker. Okay, so now just a minute.
Sir, share screen instead of PPT. Sir, am I audible, sir?
Yeah, audible, but
Sir, can
something.
you share your screen, sir, instead of only PPT?
So my slide is okay. Is it visible?
Okay, sir, but we are getting some patches like
Sorry.
we are getting some patches like you open some like dialog chat box, it seems like. Do one thing, sir. Do one thing, sir. You can see screen, sir. You just share screen instead of PPT.
Okay, so only PPT we can share. I can share.
Yeah, sir. Now you shared only PPT. You just share your entire screen.
Yeah, that's why I'm trying, but I couldn't get.
In the left side, in the right side, you just open.
Okay, so now sharing
Two screens, sir.
entire screen. Where it is in?
First option.
The screen one.
Screen one. Yeah, yeah, perfect.
Yeah, this one I already did.
The right side and all we are now it is okay, sir. The right side there is one patch kind of.
Okay.
I think it's a chat box, it seems.
Okay, chat box. Okay.
No, sir. Close all the windows. For us, it will be like patches. Like
So now it's okay.
your PPT is visible, sir, perfectly. But in the right side, we are seeing some windows, like chart window and all. You can close it. So that we.
Sorry, your voice is not clear.
Sir, on the top of PPT, there are some two small windows. I think, sir, two small windows were opened, which is covering the slide, sir.
Prashant, sir, am I audible now?
Yes, sir, you're audible.
Yeah. Ramani, sir, right side, I think you opened some chart box, it seems. If you can close it.
Okay, now close, huh?
Yeah, there is another window also, sir. One window is closed. There is another window, it seems.
How can I? Okay, is it now?
Carry on, sir. No problem. Yeah, carry on, sir. Yeah. Carry on, sir.
Actually, I'm not frequently using the web and the WebEx. Okay, so I'm using the MS Team. Okay, so now I can share my screen. Sorry for the interruption. Now is okay, clear?
It's okay, sir. Carry on, sir. Yeah.
Okay. Thank you.
Carry
Thank
on.
you so much. Good morning, good afternoon, good evening to one and all present here, because this is an international conference. So the people from global, and I thank for the opportunity for providing me here today. So the international conference on intelligent and smart computing in data analytics. Okay. So I thank the management for organizing the wonderful conference at KL University, India. Okay, so thank you so much for Mr. Dr. Prashant for giving the great elaboration about me. Okay, so today we are going to see about, or we are discussing about the IoT application in smart grids. Okay, so what are the contents we are going to see about? So first, I want to elaborate with the overview of the IoT. IoT means Internet of Things. What are the significant components are used in the IoT with the smart grid? As well as I need to elaborate grid as well as smart grid. What is the differences between grid and smart grid? And followed by recent utilization of IoT in smart grids. Then what are the challenges that we are facing? Okay, so smart grid and IoT challenges. Finally, we need to conclude. Apart from that, we have some discussion about the research collaboration after end of our session. Okay, followed by the Internet of Things and overview. Why the people are taking for this recent advancement? What are the necessity we are going to do in the research? Especially this forum is each and every researchers can able to enable our data where we can have the data. The data how we are going to transfer. Okay, so the IoT is involved the some of the sources, some common platform for the communication. Then we need to distribute some other important data, so we can reach some different loads in a sense consumer or our user. Okay, so different platform people are talking generation, transmission and distribution. Okay, these things we can have. For example, we are talking about the communication, we maybe say the different terms only, but the concept everything is same. Okay, so this one everybody knows, but the basic IoT philosophy. So we have a data storage. Sometimes we maybe call it as, currently we are calling it as cloud. Okay, cloud is a data storage. So the data storage is a huge amount of data can be stored in this platform. Okay, followed by the sensor. The sensor is an important role for our IoT. IoT is Internet of Things that should be sensing the data or sensing the information from one place to another place. We need to transfer without any interruption. Okay, so here we have many sensor we are using. That sensor is called a smart sensor currently. Okay, so the sensor can be make it some logics, whether the previously the basic fundamental logics everybody knows, the digital logic system. So that should be is used for our IoT by acquiring the data from our sensor, the both way. Okay, so followed by the data can be transferred from one place to another place by using your some algorithms. So this is your total multi-directional communications. Okay, followed by what is Internet of Things. So nowadays the people are using the smart sensor for communication. So now we can talk about the talk to each other. What is talk to each other? So the Internet of Things is intelligent network that promptly achieve grand in context of a modern wireless communications. So currently we are making some modern wireless communication. Okay, everybody we can connect each other. So apart from that, what is the main purpose of this concept is to the universal of interconnected physical objects. Okay, which is including RFID, radio frequency identification tags, smart metering, sensor, actuator, and smartphone, etc. Okay, these are the things we are going to utilize the objects. Okay, the smart metering, sensor, actuator, some smartphones. Yeah, nowadays our people are using the smartphones because We are using the WhatsApp, a Messenger, so many communication platform or communication apps we are using right now. So this is also one of the, now you see here, I am in Malaysia right now, so I can connect with you in India. So now the participant overall from globe, overall from the world. So the people is easy to connect. So this is a modern wireless telecommunication system advancement. Okay, in this case, we have the object or things are able to interconnect or interact with each of others through unique address schemes and corporate cost neighbors to achieve the common goals. Okay, so now we can talk about the talk to each other. So in addition, they connect to the cloud through the gateway or routers. So how do we connect the data from one place to another place? So we can have some general platform. So by using our gateway or routers. So this is a basic ideas about the smart sensor communication. So followed by the data generated by the sensor can grow hugely. For example, we have some data videos. So videos having some indefinite or make it more data capability, storing data. So that is called as GP, gigabytes or terabytes of the data can be video surveillance. For example, in our home, we are using the CCTV. So that can be operate one place that can be connected to the cloud. The cloud can be connected to somewhere. For example, I can operate from here to there. So everywhere the same. Okay, so in addition, we have big data issues. This is where scalability of clouds come on handy. Okay, followed by so important role. The cloud is an important role for IoT facilitators. So this is not much essential, but this is essential for communicating or interconnected with the data from place to place or some person to person. So it is very useful for right now for IoT. Okay, so some functions, important functions which are going to discuss. So the as per I'm a electrical engineers, power electronics engineers or power system engineers, we are talking about the some equipments, electrical equipment. As per as concern, the running status include temperature, humidity, air pressure, etc. of the electrical equipment in the power system. As you know about the temperature, humidity, and air pressure. Okay, these are the common platform. I mean, common terms we are using for our status. Okay, so weather conditions. Say for example, now the weather condition, how it can be. Okay, so in this followed by the electrical parameters that is monitor all the network nodes in the power system. So these parameters we need to connect, interconnect, and we need to monitor by using our internet. Okay, so another important thing is the main important equipment to check health condition or health state in the power system. So normally the power system generation, transmission, distribution, and effectively utilization. Okay, so these four parameters are using. Okay, generation, how we are going to generate. So say for example, we are generating the power, AC or DC power can be generating station. So the generating station, so we want to transmit the power one place to another place. Say for example, that is called as generation as well as the transmission. So the transmission, how we are going to effectively transmit without any interruption or losses. So that can be monitored where we are lacking. So that we are using for the IoT. So the distribution, so we have some grid. So the grid can be distribute the home appliances or home or consumer or business points so that we can communicate or we can connect or we can analyze, we can monitor all these parameters in a single points. Okay, this is another management information technical personals. Okay, followed by the service condition of environmental protection equipment, then controllability, observability, self redemption of power system can be accomplished for association between equipment and personal management. Okay, so now we are already we were programming, or the system can be already developed. So system is automatically performing. So how you are performing? So that the task should be performed by your machines. Okay, so now how do we interconnect with the person? So these are the things which is included in the IoT. Okay. Next, the sensor. Sensor is rolling a major role for our IoT. The sensor is typically measure or identify the particular physical quantity. So now we are sensing and the physical quantity. So followed by the sensor convert the physical properties to the electrical quantity, electrical signal. It is easy to understandable for the machines. The sensor and other things will be for your monitoring of our systems. So I can show some videos so we can easy to understand. Okay, so now I can click the videos. So these are the some basics which we are going to see. Is it visible? Is it visible for you? Can you please respond? Anyone? Prashant? Yes or no? Anyone, please? Is it visible? Okay.
Yes, sir. Visible, sir.
Okay, thank you. Okay, thank you for watching. So maybe you can have some great ideas about these things. Okay. So continue with our lecture. Okay. So the sensor we used, right? Okay. Next, we want to see about the common platform. This one is not. Okay, so IoT application with an embedded system. Say, for example, we are controlling the battery from the source side. So we are having some equipments. So that equipment we can call it as embedded system. So embedded system which is covered by sensing elements, processing unit, communication, wire or wireless. So followed by the applications, and we have many tools. So then we can connect with the gateway and we can pass to the cloud. So the cloud can be make it as some data storage. So whenever we record, so we can make it both way bi-directional. So you see the cloud can be retrieve the data through the gateway, again the application, then we can make it a bi-directional by using communication, processing unit, sensing unit, then monitoring of the battery systems. Okay, followed by and the IoT system with the smart sensors. So okay, so now we are connecting the wireless communication or wireless or smart sensor nodes. So we are having some inputs to the node. Say for example, we are using the mobile phone without connect any device, wired device. So we are making some sensor or some protocols. We are using that. The same way we can collect the data from your gateway. So now the cloud can be data connections, then data processing and analysis and useful information. These things we are make it called as clouds. So the clouds can be store the data from wireless some from here, the information decision. So these domains which is called as IoT system with smart sensor. This is a typical, previously we can say that a typical architecture. Okay, so followed by the gigant IoTs, so multi-sensor nodes with multiple clouds. Say for example, here we have many clouds systems are there, but we are using some many user. Okay, so how we are going to connect? So multi-sensor system can be connected with multi-cloud system. Say for example, you here, so I can connect some multiple connections with the multiple sensor or multi-sensor systems. You see, now we cannot imagine how the people are going to interconnect. So here, suppose if you connect the informations without any interruption or without any loss of data. Okay, say for example, if I am talking to you, so what I talk that should be you can reach us. So that is called as communication. The same way we are going to connect with all the nodes with use of our clouds. Okay, say for example, previously we are using the M2M. M2M is nothing but machine to machine. So the 2.0, now we are having a 4.0. So now the system can be enlarged as well as developed a lot of things which we have. So now we can see one by one. So the previously the M2M, the performance constraint. So we have many constraints for the M2M, but here powerful embedded system which we are using by you can connect in the clouds. So hardly we have some standards, but here we are using the machine open industry standards. So previously we studied in the C++ for the some constraint human resources. Now we are using the Java, some other platform, some other algorithms we are developing for the communication coding. Okay, the same thing. We have so many advantages over M2M for your IoT. Okay, so I would like to share some difference of M2M as IoT. So for example, machine to machine is about direct communication between the machines. So we have two machines. Okay, this machine can be connected with the other machine. So the data can be transferred from the machine to machine. But IoT, so the same thing, but the thing is connected to the internet via internet. So IoT is about sensor, automation, and internet platform. So M2M, there is no internet connectivity or there is no sensor is used. But here the sensor can be sensed the machine to machine. You maybe studied the control system. we are making as a open loop system as well as control closed loop system. So this IoT is one of the closed loop system, which maybe we can say that. So now the machine to machine, the smart machine can be do it for this task with the intelligent manner. So your conference is also saying that intelligent. Okay, so in the intelligent system, the smart system. Okay, say for example, it support point-to-point communication, only one-to-one communications. Suppose if you study in the communication, simplex, duplex, these are the things you may be studied, one-to-one communication or point-to-point communication. But in this case, we are connecting in the clouds, so it can be communicate anywhere else, any multiple user. Okay, so other important points, device do not necessarily rely on an internet connection, but here definitely. So the device relies on an internet connections. So followed by machine M2M is mostly hardware based technology. But in the IoT, we have both hardware as well as software technology. Machines normally communicate with a single machine at a time. But here we are making a many user can access at one time over the internet, because internet is a data storage. Maybe we can communicate easily with Wi-Fi. So many platform we are using. So followed by the last one, the device can be connected through the mobile or other networks. So but here the IoT data delivery depends on the internet protocol networks, IP. We have studied some many layers. Okay, so next one, I would like to share here the traditional operational technology solution, inflexible and independent dependency. So machine to machine, you see here we have only one nodes that can be connected for your transport only. So another one is healthcare. Another one you can see logistics, security, and surveillance, followed by the industry. So this one is not interconnect with all the devices. This one we used in the previously. So currently the IoT comes. So the IoT can be connected all in this same level, that is called as cloud. So you can see the next slide. So decouples producers and consumer of the data, IoT. You see all the networks can be connected to the clouds. So that can be the data can be transferred from the storing of the data from the clouds. Okay, we can easily monitor in the transport system, healthcare and medical system, some industry energies and security, surveillance and logistics. These are is connected at a single point. Okay, this is a major advantages of IoT. Okay, another important thing is distributed system fundamental success. We have machine-to-machine integration platform and multi-service gateway approach. Previously, machine-to-machine one-to-one communication, but here the IoT is involved multi-service gateway approaches. Okay, as you can see now the platform, previously we are talking about the IoT, Internet of Things. So now the Internet of Things, not only in the smart grid, we can connect anywhere else. So now our aim, this topic, we are going to cover the smart grid. So that's why we are going to connect with the first phase for the IoT. Second phase, we are going to interconnect with the smart grid. Okay, this figure is illustrated for the IoT to smart grid. So how it can be connected. So now we want to see what is grid as well as what is smart grid. So everyone knows grid, electrical networks. Okay, this is a electrical network that can be generation, transmission and distribution. The distribution side, we have a grid. So the grid can be distributed for our home appliances, or power can be transferred to the any loads. Okay, so smart grid, intelligent electricity network. So what is the intelligent here? So what is a smart here? What is the intelligent? What is a short? What is the quick response or brilliant? So these are the smart or intelligent. Okay, so how we are going to connect? Okay, so in this smart grid, they automatically monitor and manage the grid. So grid, okay, for example, in this evening, we have a peak load sharing. Okay, for example, everyone is going for our home, so we are utilizing our power systems. Okay, in this case, we does not have much on the power system. So sometimes power cut may be there. So how we are going to balance the load? So by using our IoT or smart grid. So the smart grid where we are lacking, for example, industry is not running or university is not running in the night duration. So that load can be shared by automatically. So that is called a smart grid. Okay, using the smart meters and other smart devices, it is used for our smart grid technologies, followed by the gain insights about usage of battery, better management. Okay, so these are the management which we are previously we are using manually the grid. For say for example, we can use for our grid. So manually we can operate it before one or two decades. So currently now we are making the smart grid. So the smart grid, the machine can be performed automatically without any human helps. Okay, so this is called as I mean smart grid with automation. Okay, say for example, load balancing, accident prevention, theft detection, reduce the power and revenue losses. Okay, so just now I explained to you about the load balancing. Okay, accident prevention. Sometimes the overload will be there. So short circuit may be occur. So during the short circuit, so how we are having a plenty of internet connections. I mean interconnected the power system. So we cannot easily identify, even though we cannot go into the, we cannot see in the place exactly. It may be in the remote areas. So now how we are going to monitor? We are having some sensors. So the sensor will detect the what is the happening or what is the fault, so that is easy to understand or easy to monitor all the things. Another one is theft detection. Sometimes there may be we can use some people are using the theft, so it is easy to identify where the power can be consumed. Okay, so another one is reduce the power loss and as well as the revenue. So everything is business related, so the cost is involved. Okay, so without any cost and they are not having much things. Okay, so now we are making some revenue for the making some losses. So once we can cut the losses, automatically we can have the proper loading. Okay, so these are the things, these are the important things for two-way flow of electricity and information. So previously the grid only the electricity, they transfer the signal or transfer the power from one place to another place, but there is no information. But the information communication, so which is involved in the smart grid. Okay, so what are the important components for the smart grid? So smart appliances, smart metering, smart substations, and synchronous phases. Okay, so these are the important components we are using. So I'm showing one more videos. Okay, I can share to you for the related with this grid. So just 5 minutes videos. Okay, thank you for watching the video for about the smart grid. So previously we are operating in the manual system. The smart grid can be connected through via without manual. Okay, so it can be operate as a machine. Okay, machine can be do anything without any manpower support. Okay, so these are the important for our smart grids. So how we are going to connect with the smart grid as well as the IoT. So now the IoT is mainly considered for the smart sensors as well as smart meters. Okay, so say for example, already we are talking about the smart sensor and metering. So smart sensor or smart metering accumulate the energy, use the data and show the full picture of the energy consumption in the house, including loads and estimated cost. So this one is automatically sense or intelligent or brilliant with the sensors. So that can be operated by our smart sensors. In followed by the automation and distribution. So the automation and distribution using the IoT automatically and self-management. So say for example, any fault occurs. So we need to sense manually previously. So now automatically the sensor can be sensed and we can identify where the points can be disconnected or where the points can be lost. So that should be self-learning or self-management. So by using our some algorithms that is called as automation distribution. Another important thing is charging station and storage, smart storage. In the concept of smart grid, the energy storage and charging station play an important role. Also reflect the growing demand for the independent residential renewable energy systems. Okay. So you see the architecture, smart grid architecture. So now previously what we discussed, the cloud can be connected all the things. Now the smart grid, especially in the power system, so we can connect the power generations. For say for example, renewable. Renewable mean we know the solar, wind, thermal. Okay, so these are the things we have. Thermal is another part. Okay, non-renewable. Okay, so here the conventional thermal power station, hydraulic power station, some unclear power plants, factories, home and cities and offices and business unit, ecological vehicles. So these are the connected with the smart grid. So this is the showing for smart grid architecture. This is a typical architecture. Okay, so in this case, IoT enable home storage devices intelligent, interact with a smart grid. So that can be understand the peak demand period. So say for example, if you want to record or if you record the disconnect the home circuits from the grid to supply power on your own, or it can be added. So that two things we can monitor or we can do manually previously, but the smart grid, so automatically that should be connected or disconnected depends upon the load sharing. Okay, this is a smart grid with IoT, the sensors. Okay, so another the continuation with this, the role of IoT, the smart grid is crucial. So IoT, the Internet of Things, is a large part of the enabler of smart grid as the intelligent technological and infrastructure components are mostly used in the IoT based. So followed by the data on the energy consumption comes from sensor enabled IoT device. So which is called as IoT and the sensor enabled IoTs. So the appliances, hubs, which can be controlled by the smart houses. So smart houses, in a sense, we are connecting the sensors with internet facilities. Okay, so that is called as smart houses or any other connecting spaces. Say for example, we may be connecting the office also, smart office or smart industries. Okay, so it can becomes in near future. So the smart office as well as smart industries will become because the without manpower. So that's why our researchers are going to be contribute many research in these areas, IoT, smart grid, and all other things. Okay, this data is then used to analyze. Okay, what is the purpose? Why we are going for the smart grid with IoT? to analyze the electricity usage. Okay, say for example, the last month, what we have the electricity usage, how we are going to reduce the electricity usage. So this one we are using for our analysis purpose, as well as calculating the cost, followed by control. Remotely we can control the home appliances. Suppose now, say for example, you are stay alone, okay, you are making some smart houses. Okay, suppose if you forgot switch off your fan or light or any other loads, so you can remotely access, you can remotely operate whether you want to on or off. So this one is used for our IoT. So another one is making decision of load distributions. Recognize the device, where the device, or sometimes it can be theft or some detection of malfunctions. Sometimes it may be it's unnecessary usage of our power, so that can be easily detect. And also risk of outage. Sometimes it may be theft or sometimes it may be fire. We cannot go there, so we easy to find out. Okay, I think this video maybe you can see because we have only 10 minutes more. Okay, maybe I can leave it to you later. Okay, the smart grid and IoT is real-time data analysis as well as a visualization. So real-time means data enable automation, control, management, as well as the problem detection and prediction in the smart grid. So followed by advanced algorithms. So we have many algorithms, so we are using. So this algorithm can be analyze the IoT data created in the smart grid networks. Okay, so IoT, Internet of Things, what is the changing the environment or changing the energy sector and added value chains. You see example, the consumer role in energy management and conservation. The other things is also we are using some renewable energies and increasing the reliabilities, as well as this challenge demand by dynamic situation as well as the pressure reality situation. So these are the some challenges are energy sector. In addition, you can see the load profile, demand response program evaluation, detection of energy theft, grid losses, data analysis, modeling of new programs, followed by so many analysis and distribution network planning, where we want to share or we want to cut the power. So outage analysis, these things we can analysis from your IoTs. Okay, so what are the challenges that we are facing? So currently the IoT is going on. So in addition, we have facing some difficulties. That's why the Congress or these conferences we are mostly conducted. So these conferences is about the Internet of Things. Okay, say for example, many experts are working in this area. So some difficulties are facing. So I am going to list some few things for the challenges. First one is privacy. The consumer data shared over the grid and snooping, invasion and profiling possible. So some privacy is missing. Another one is security. Even though we are having some proper security mechanism, but this phenomena is not properly working for right now. So some after maybe few maybe 5 or 10 years, 2030 or 2035, I mean 2035, that should be sort out all these issues, especially for security, cyber security. Already you know about these things. Anyway, this one neutral disorder, physical, cyber physical attacks. So these are some securities will be make it for the challenges. And fairness, how to distribute the fair share of the resources. So sometimes still we are struggling for the smart grid is enabled with the IoTs. Okay, last we need to conclude. So it can be addressed the overview of IoT today's and various usage of the grid technologies, and also we talk about the various intelligent services can be created and develop of the most aspect of the smart grid would be enhanced by the applying the IoTs. So IoT normally we can say without manpower we are using. Okay, the smart metering or smart sensing that can be automatically will detect as well as resolve all the issues. So these are the things we have seen in the past 1 hour. Okay, so these are my references. I can take it from our outsource. So these things you maybe see. Okay, this is my contact details. You may be contact at any time by using via my email. Okay, ramani.kannan@utp.edu. That mine. This is my official email. Another email is ramani.kannan@ieee.org. So this is my website. Maybe you can see. Okay, thank you so much for attending this keynote session. And now you can open for your questions and discussion. So after this, I want to discuss some research collaboration. So now I can stop my presentation. Okay, can you have any questions? Let me ask. We need to discuss the collaborations.
Thank you so much, sir. Thank you so much, Ramani, sir. It was nice presentation, actually. I request faculty members to post your questions in Q&A session.
Okay, any questions? Okay, I can talk about the research collaboration between KL University as well as University Technology Petronas. Currently, we are offering many research collaboration from our University Technology Petronas. So you are always welcome. Say, for example, I can say some student mobility perspective of the student. So we can exchange the students to transfer the student for say for example, research attachment program for 2 to 3 months or more than 3 months. So we have some students from India, so they are working under us. Okay, different disciplines, especially for circuit branches, IT, computer science, ECE, EEE backgrounds. So in addition, we have some joint supervisions as well as the research publication together with two different affiliations. So that may be useful for our QS ranking. Okay, everybody is going for a ranking. So that should be useful for us or for the student community as well as our staff, faculty. So in addition, we have some master as well as PhD program. So the master as well as PhD program, we are offering the stipend. Say for example, master we provide 1,300 ringgit for masters, 1,600 for PhD students without any payment taking from our student. Okay, so these are the facilities we are provide the open-ended globally. So many Indian students are working with University Technology Petronas. So you always welcome for the research collaboration. Thank you. Thank you so much. If you have any doubt, you maybe ask through email or maybe you can ask now. I think 2 minutes to go for exact time.
Sorry for interruption. There are some questions. The first question is, what type of sensors we can use in smart grid?
Okay, this one is depends on the sensors. So normally we have many sensor we are available. So where we are going to use the sensor, so the sensor is depends on the applications. So we have plenty of sensor are used. Okay, so this one is depends on the loads or depends on the locations where we used. Any questions?
I'm checking the questions from YouTube live stream, sir. Give me 1 minute.
Okay.
There is one question, sir. What is the future smart grid technology like? Sir, am I audible?
Sorry?
Shall I repeat once again? Am I audible, sir?
Yeah.
Yeah, I'll repeat once again, sir. No problem. Yeah. What is the future smart grid technology like?
future technology?
Smart grid technology.
Sorry, I couldn't get you. Smart.
Like, what will be the future smart grid technology? Like, the question is. That's okay, sir. No problem.
So, actually, I did. Yeah.
I'll once again repeat, sir. No problem.
Mm.
Am I audible, sir?
Yeah. Now it's okay.
Yeah. What is the future smart grid technology like?
Future technologies, smart grid.
Yes, sir. Yes. Yeah.
Okay, so now previously what I discussed with the grid as well as smart grid. So the grid means the without manpower can be used for on or off, or maybe we can share the load. So currently the situation we are using the IoT enabled smart grid that should be we can use for our internet. So by using our new sensor, the sensor we are plenty of sensor we are available. For example, you are controlling the speed, the speed mode. Control of speed control of the motor. So we are having some what is it, and the closed loop system that should be used for the sensor. So PI controller, fuzzy controller. So these are the optimization techniques which we are using the previously for our things. So now the same intelligent technique will be used, but in this case we are connecting with the internet, so we can operate through our internet mode.
Perfect, sir. There is one more question.
Okay.
Yeah. Is there any like optimized techniques for network reconfiguration for distribution system?
Sorry. Can you please repeat?
Any optimized techniques for network reconfiguration for distribution system?
Correct. Okay, in this case, we have studied many layers, right? Application layer, presentation layer. So these layers now the people are using for the artificial intelligent techniques. So the intelligent techniques which are using for our, for say for example, power system, which we are using the optimization. Optimization is in a sense GA, genetic algorithm. Genetic algorithm is an old one, but anyway, this is a basic. So genetic algorithm, PSO, ant colony, firefly, so bad algorithms. So these are the algorithms will be used for the power system to optimize our load sharing, or you can easily find out. So everything is controlled by the algorithms.
Perfect, sir. So there are some other questions. I'll just do one thing. I'll just send out all questions to your email ID.
Okay. I will send to you. Okay, thank you.
Thanks for your presentation, sir.
Okay, thank you so
Glad
much.
to have in our conference. Yeah, thank you so much, sir.
Thank you so much. Thank you so much for giving the opportunity, Dr. Kola Banu, as well as our computer science departments. Thank you all. See you again.
Welcome, ma'am. We will
Hello.
start at yeah, welcome, Dr. Katina Michael, ma'am. We will start shortly at 2:30.
How are you? You sound a little bit choppy. I'm wondering if there is a problem with the network on my end or your end. Can you try saying something again, please?
Yeah, ma'am. Pardon me. We will start shortly at 2:30, ma'am. Welcome. That
can't-
is going to join.
I can't hear you that clearly, and I'm worried maybe it is my end. The internet is slow, or perhaps it is your end.
No,
You're perfectly audible, ma'am. Your voice is very
Yeah.
clear.
Okay, so long as you can hear me, it's okay if I can't hear you, but perhaps people will have to type in the chat.
Sure, ma'am.
Okay, friends, can I get some water, or you wanted to do some testing of to share my screen? If I share my screen now?
Ma'am, we will start at 2:30, ma'am. Let me give it
Yes.
briefing about you, then we can start the sharing of the screen.
Okay, so right now we leave it, and I can come back in 10 minutes. I leave everything on and just go and make myself a cup of coffee and come back.
Okay, ma'am, sure.
Is that okay? Yes?
Sure, ma'am. Sure.
Yeah, sure, ma'am.
All right, Surya and Dr. Raju, Anitha, thank you very much for testing this. I will be back.
Sure, ma'am.
Okay.
warm good afternoon, everyone. I, Dr. Raju Anita, Associate Professor, Department of CSC. Welcome you all to the keynote address by Dr. Katina Michael. I take the privilege in giving you a brief about our keynote speaker for this session, Dr. Katina Michael. Dr. Katina Michael is a professor in the School for the Future of Innovation in Society and School of Computing, Informatics and Decision System Engineering at Arizona State University. She researches predominantly in the area of emerging technologies and has secondary interest in technologies used for national security and their corresponding social implications. Like many of her colleagues at SFIS, Michael realizes the importance of examining the risks and potential consequences of emerging technology and sciences. She has held visiting academic appointments at the Nanjing University, China, and the University of Southampton, UK, and has taught at the Singapore Institute of Management, as well as overseeing UOW Engineering and Information Science courses in the 8 campuses in 5 countries. In 2017, Michael was awarded the Brian M. Goodall Distinguished Service Award from the IEEE Society for the Social Implications of Technology. She is the founding editor-in-chief of the IEEE Transactions on Technology and Society, which will be launched in 2020. Before finding her way to SFIS, Michael served as Associate Dean International at the University of Wollongong, Australia, where she was employed in the Faculty of Engineering and Information Sciences. As for why she decided to pack up and move to the state to join the faculty at SFIS, she said, "I think I was always meant to be here. I grew up in country New South Wales." She laughed. But aside from that, she was the people here, and I had been in London working at the same campus for 17 years. So for me to leave, it had to be something really special. Welcome to Dr. Michael. And the participants, please, you post your question and answers in the chat box it was given. At the end of the session, Madam will give the answers for you. Please welcome ma'am and continue your presentation.
Thank you, Dr. Raju and Surya and Dr. Banu for all the support in getting to this point. To KL University, I appreciate the invitation to the Intelligent and Smart Computing Conference. To begin with, just to mention, ladies and gentlemen, I'm currently in Australia. I do work for Arizona State University, but given COVID, I've been thrust back to Australia. And so today I have prepared for you a presentation, a full-length presentation, which looks at the black box within. Okay, so I really want you to think social implications in this talk because I'm a member of the IEEE Society on the Social Implications of Technology. I'm also a member of the IEEE Consumer Technology Society, recently changed its name. I'm a board member of the Council of RFID. I'm a member of the IEEE Brain Project and Standards Project in leading as a working group chair for P2089. And of course, my beloved Arizona State University, where I direct the group Society, Policy and Engineering Collective. I'm in the School for the Future of Innovation in Society, which is very much a new school, about 5 years old, and I'm a joint hire as a tenured professor with the School of Computing, Informatics and Decision Systems Engineering. And given these two areas coming together, I would say I'm fairly transdisciplinary. We've been seeing over time, IEEE has begun to request these global challenges require global solutions that are in fact transdisciplinary. And so today I'll be jumping between disciplines and I'll be doing that unashamedly. So sit back, relax, and I hope to take you on a tour of the black box within. As a highlight in the context of this talk, I wanted just to say a few words. I began my full-time work as a network engineer. That's what it said on my employment offer letter, graduate engineer, and that was around 1996. I began my PhD the following year in 1997, 2 years before the term Internet of Things had been coined by Kevin Ashton in 1999. And I say this because it was from the outset that I felt that things would be tagged. It wouldn't just be barcodes, it would be smart devices that would basically follow us around And it was the concept of the follow me number, which emerged around 1998 through the ITU, which I was studying heavily with my colleagues in Wollongong, Australia, at Norton Networks. The follow me number, what did that mean? And what if there was a follow me tag? And what if you could remotely request a transaction, a GET request from a tag that was somewhere out in the field? By 1998, the company I worked for, Norton Networks, which was in 150 countries at the time, before it went bankrupt in 2005, they sponsored a project called Cyborg 1.0. And Cyborg 1.0 was literally taking a transponder implant the size of a grain of rice and putting it in the left arm of Professor Kevin Warwick. And that $200,000 project sponsored Dr. Mark Gasson, and actually went through the potentiality of a professor holding a smart tag inside his body for a period of 10 days. Of course, that was followed up in the 2000s, early 2000s, by Cyborg 2.0, where Kevin Warwick and wife Irina were actually communicating through what they call Morse code in these implantable chips that were embedded in their body. In 2002, I finished my work in pre-sales engineering. I had great exposure throughout Asia, but also North America. And I became a member of the IEEE SSIT community in 2004, a couple of years after I began my formal academic work at the University of Wollongong. I was an integral member of the Research Network for a Secure Australia between 2005 and 2013, and later a Centre of Excellence on Policing and Security. I also completed law studies in transnational crime in 2010. And this is just an overview to give you a context of the backgrounds and backdrops that I'll be thrusting upon you in the next 40 minutes or so before question time. So the outline, literally, we're going to do 4 things today. We're going to understand what are black boxes and what is Katina talking about when she's referring to the black box within. Within what? The human being, perhaps. We're going to discuss operational scenarios as were described and defined by NIST. We're going to talk about uberveillance and the antecedents of this novel concept and social implications. What do we mean about the black box within? What could be some of those unanticipated consequences, as well as anticipated and unintended and intended consequences? So let's begin this first segment looking at open systems theory. What is the black box? Traditionally, what have we understood when we look at open systems as opposed to closed systems? We have an input, of course, there is some processing in the middle, and there is an output. And then we have this dotted line boundary with the surroundings, the external environment. Well, the black box is that which sits within. What happens there? What are the interactions that take place? And we could have simplified closed systems, very complex open systems. And as we see, the world is increasingly becoming complex because of the transactions and their meshed nature. We no longer rely on the knowledge that it's one single organization that creates the actual footprint of digital data. In fact, there could be subsidiaries involved, there could be partnerships, alliances, and all of these different business models by which something happens in the open system. So input, processing, output. And that thing in the middle, that open system, is what is traditionally called the black box. When we speculate if there can be interventions to a black box and what that might mean, sometimes we call these experiments. There's an input, there's a process, the black box, and there's an output. But if there is an observer, perhaps an agent looking in, we could be running an experiment. But in which fields are we talking about? When we talk about black boxes in software programming, what does that mean? The AI is doing something perhaps, or this object-oriented program is doing something we don't quite understand because it's calling on libraries from all of these different places. In physics, it's actually a black box artifact. It's something that is physical in nature. In cryptography, we talk about the black box encryption algorithm that nobody is supposed to know about. In testing, of course, we see these experiments and black box kinds of testing, mathematical modeling where there are limited cases, and of course, this great notion of artificial intelligence. Well, what is the AI program doing? Well, who knows these days? It depends. And on whose data has it been trained on? Oh, well, this set of data, but is it biased or unbiased? And so with this recently, my colleagues and I at the Transactions on Technology and Society, that's Roba Abbas, George Rissos, Eusebio Scornavacha, and Samuel Fosso Wamba, we looked into the design of autonomous systems and their applications. And what is so different? How do we imbue ethics in AI when we are not actually knowing exactly what's happening in the creation of the AI or the autonomous system and how it acts? Think about human in the loop, human out of the loop. Think about the algorithmic mystery that comes with a black box, a product, and perhaps corporate environments protect this through a patent. They say, this is my perhaps KFC secret sauce. This is my formula to Coca-Cola. But in actual fact, they're talking about a product that's electronic. And that company code is what they're trying to protect through the patent or the algorithm. And so that's an algorithmic mystery. In the second type of black box, what we see is a concept defined by M.G. Michael back in 2006. It's an embedded surveillance device. It's technologies that are embedded that we cannot see in all sorts of different devices. And in particular, the notion of uberveillance pertains to the human being. So I want you to think about a flight data recorder that is in airplanes versus that which is an embedded microchip implant that's tethered inside the human being. So imagine this airplane that has a black box recorder in case it goes down and something goes wrong. And so the observers and those investigators after a crash, they recover the black box so they can hear what is happening at the cockpit and the conversation between the pilots, but they can also look at other information about altitude, speed, and all of these sorts of parameters that are relevant to a crash investigation, an accident. So imagine if each one of us carried one of these microchip implants in the human body that was either medical or non-medical, and that implant could be tethered to a device like a smartphone or a tablet or a dashboard somewhere remotely. Imagine the visual data recorder could be worn or lugged around. Perhaps I would put it on my belt buckle or in my back pocket, or is perhaps the mobile phone a type of black box? But here, when we're talking about the black box within, we are talking about uberveillance. We are talking about embedded surveillance devices like those carried by heart pacemaker recipients that monitor what is happening in the body, such as those who are holding glucose monitors if they have diabetes type 1, for instance. And so I want to paint this picture and embed this picture in your mind. What we're talking about today is data analytics from within the human body that tells us not only who it is, where it is, or what condition the individual is in, perhaps by monitoring vital signs and characteristics, your heart rate, your pulse rate, whether you're sweating, whether you're stressed, all of these other things, whether your body has had a temperature elevation beyond that 36.7 Celsius. So this is akin to having this red box, this flight recorder in the human body. And many people are posing that this is our future. So identity, location, and condition. And that denotes uberveillance. So let me take you again. We're here in the sky. We're in an airplane. The airplane has a black box recorder. It's recording everything. We start to get through the mist. We get down to at a lower altitude, and then we can see more. We are seeing more in terms of visual analytics. We can now see paddocks, we can see houses, we can see farmhouses and other things like silos. We can see divisions of land use. We can see mountainous areas and terrains. We have better visibility by watching. This is actually, ladies and gentlemen, data. It's geographic data, data that we've seen through satellites. We also have orthographic photography that takes photos over a landscape, a terrain. And so as we're getting closer and closer to landing, we're seeing more and more of the landscape. This is exactly what this conference is about: intelligence and smart computing, smart devices, and data analytics. And as we get lower, the resolution is greater, okay? and we are able to understand the surroundings and do calculations. Perhaps I want to know what kind of pest control I could place over this area that we see here, if there is enough water in the dam, if I need to increase. But now we have sensors that are sprawled all over the place, environmental sensors that can tell us this information. We not only have the photographs from the satellites or the aeroplanes, we now also have ground sensing devices that tell us about the environment around us. And so we can see cars now, we're on the street level view, and we can see the surrounds around us like the air traffic control tower, and now we're at street view, okay? We've left the aerial view, we are at street view. And so we take this paradigm of a black box recorder, as is denoted in this presentation, like the flight deck recorder, and we can see a black box car insurance offering here. What does that mean? A black box car insurance. So we not only have them in the planes, but we also have them in the vehicles. This is a device that is able to tell a parent where their child is, and also to lower the car insurance premium that they are paying. I can use my device to toggle remotely on the surroundings of that vehicle and make sure my son or daughter is not speeding, is not cutting corners too quickly, is not braking too hard at the lights and causing trauma behind them. But you can call this telematics. It could be perhaps what we're talking about, telematics of the human body. So imagine the globe, but instead of the globe, you are the globe. Your body is that entity that we are investigating. Katina's heart rate, Katina's pulse rate, Katina's temperature levels, Katina's stress levels. And so we've gone from the flight deck recorder in the aeroplane to that in the car. And what about in the house? I think perhaps we have all invested in hub devices that can now let us control. Your home is an ecosystem. In fact, it's a closed campus system, but we are now using this device to tether to our hub to basically change settings on temperature, okay? Air conditioning, change the lighting, perhaps make it dimmer as the evening wears on, and we can save energy. Perhaps we want to have music play as we enter a particular walkway or having a shower or whatever. It's all customizable. So from the airplane to the car to the home to the human being. Ladies and gentlemen, when we talk about the last mile traditionally in networks, we've always talked about the end user. Basically, we're talking about how do we have broadband coverage in most areas, and then that last mile, which is to the user, the tail to the home. If there is no fiber to the curb or fiber to the home, how do we do that wirelessly? And increasingly, we are coming out with different solutions like 5G, not just 4G. And so now what we have for the first time in human history is the capability to actually wear sensors on our bodies. We not only have to wear them or can wear them, we can tether to the devices that we carry and lug around. So my wearable can talk to my mobile phone. For example, maybe I have an Apple Watch that is communicating with the Apple phone. But we're also talking about what could this body area network? It's not just a metropolitan area network or a regional area network or a wide area network or a local area network in a building. We're now talking body area networks, and where there is data to be taken, it will be. Okay, and so the question then becomes, who owns this data that is being collected around the body through wearable devices and implantable devices? And if we have a heart pacemaker, an Apple phone, if we have an Apple wristwatch, if we have a glucose monitor, if we have another wearable device like a headset that never comes off our body, perhaps we have additional things. COVID safe apps, for example, as technological responses to the reduction of the transmission of COVID. Whatever it is, we are now starting to talk about the emergence and the requirement of what's called a gateway. It's like the hub, not in the house, right? So you have your Google Nest, for instance. It's a hub that is on your body, and maybe that is somewhere around here, the gateway there near the belly button. The access point is several meters away at most to anything. So because we're talking about near field communication, most likely, or Bluetooth enabled low energy, or we're talking about other devices that require to be triggered by power because their power source perhaps is dormant for the greater part. What we need to think about is that these are the kinds of applications we are talking about when we're talking about body area networks. They are tethered within distance, within near field, within radio frequency field, within Bluetooth range, which could be between 2 and 10 meters at best. And so what happens when we start to look at applications that gather data from wearable devices or implantables? We start thinking about things that could be to the nearest. Okay, what do we frequent? Entry and exit gantry points, but what does that mean in reality? And we're talking about electric fields, electric currents, electromagnetic communication technology, basically wireless devices, not something you have to plug into somewhere using a USB stick, for example, or something like that. And so a famous business researcher from New York University, I believe his name is Holloway, talks about this requirement to almost circumvent the capability of someone to retain their own data. You know, he used this beautiful depiction here. Sorry, it's Galloway, not Holloway. Scott Galloway. The 4 what to do. So he talks about Google, Facebook, Amazon, and Apple, and he says they're almost empowered to own different parts of the body at the moment. Google has the search engine brain, Facebook, the heart, because that's where we have our connections and social media and relationships. Amazon, the gut in the sense that if we want to buy something, the wants, the desires, the needs, we can just go to Amazon Prime and buy to our heart's content. And Apple, of course, dubiously there depicted. So what we have here is basically an end-to-end ownership of data when you think about it, the mind, the heart, the gut, and so forth. And this is how data is actually emanating out of the individual. And when we start to study data analytics, what you are probably going to be thinking about is what happens when we collect information on fault tolerance from heart pacemakers. Of course, we are aware of the major row and debate going on about who owns heart pacemaker data. Is it companies like Medtronic, or is it everyday patients who actually consent to getting one of these pacemakers put in their body? That's the question today that we have. And so the truth is the patient does not own this information. It's actually the provider of the device that owns it. And so here we see another example of an implantable device that was demonstrated by the company Autodesk Research in 2012. This particular device, you can see here carved out on the forearm of this man, had a tap sensor, a tactile button, and a pressure sensor in order to allow for almost two-way communications. I would type as I requested a particular service of the implantable. This was just one device. And so in our work with MG Michael and Dr. Roba Abbas, what we have seen is this constancy towards miniaturization, this constancy towards knowing the last mile, that we need better visibility, better data, more data, and we have to do more effective things with the information. So we've gone from the satellite view, the street view, to the person view, to now what we're calling the sensor view. And perhaps we are now talking about implantables for the mass market. I want to make it clear here that I'm not a proponent of implantable technologies apart from devices that are life-sustaining, like those that have to do with defibrillators or heart pacemakers, or, for example, insulin pumps, or last resort requirement for deep brain stimulation, DBS devices, brain pacemakers for those who require them, suffering from Parkinson's or Alzheimer's. But we are witnessing here, when we are looking at these trends, we are witnessing from this big view right down to the minuscule view. And that view is, you know, for many providers, it's not just enough to know what you're doing on the handset. They want to have solutions for in-body, and that has massive social implications, but also ownership implications. Who owns the different kinds of data characteristics? Who has the right, if it's bi-directional flows, to communicate with your implantable devices or your wearable gateway that you wear on the outside? And so these are all questions that raise a number of human rights issues, privacy issues, issues to do with consent. So let's move on here to quickly look at the operational scenarios. And here there are three: in-body, on-body, or external. And then those three kinds of scenarios, when we relate them to one another, come out with about 9 in a matrix. So my implantable, can it actually communicate with the mobile phone, which is external? My implantable, could it communicate with a wristwatch? And what does that mean? So from in-body to on-body. And we depict this in the latest article in Transactions on Technology and Society with the author team. And we look at this from the perspective of in-body devices within the human, on-body devices that are human-centric, and on-body or in-body to the machine. That's external. And I would call this a machine. I'd call a lamppost a machine. And if we were to look at these diagrammatically, imagine my device is talking with other devices like external devices. Imagine my implant is communicating with near-field communication devices. Imagine my implant is communicating with FPOS machines at the point of sale. These are things that I could be wearing, and they're communicating with external devices. And what if, for example, I have an implantable here on the left that allows me to interact with the world around me, either to a kiosk directly, an RFID reader, or any other device that's external, like a lamppost. And so imagine this man is walking past, he has a wearable hub, he has implantables, and the lamppost is able to send a transaction of data. Hello, lamppost, perhaps, is what we'll be saying in the future, and the lamppost may be responding, hello, Dr. Michael. And so this is a transaction, and we're already starting to see this with lampposts and everyday devices that we carry, although some of these things are happening covertly or with limited knowledge. For example, there are many shopping malls today that look at how their customers in the shopping mall frequent the surroundings using data analytics and location information to know where the customer is, where they stop and look at a shop window and a shop front, for how long they stay there, what kinds of paths they may take when they go to the shopping mall. And so these devices are already communicating machine to machine, but some of these machines happen to be worn on the human body or in a belt buckle. And so these scenarios are becoming prolific. Here are all the things that I could do if I was gaming with an external device. I'm wearing a wearable unit and I'm playing with the Kinect. And this data is actually doing something here. You know, it's not only the movement of the mapping that occurs as I move around in front of the Kinect, but there's also other things happening there as well. It's capturing other data. It may be capturing my reflexes if it's a game of tennis that I'm playing with, or a dance, and how good I am, and giving me statistics about this. Now, imagine we were doing this with an implantable device, and all of these things that you see here about acceleration and position were actually the heart, were actually other parts of the body. And this is the information that may well be transacted in the future. We can look at tethering to wearable devices, from wearable to wearable. We could look at an implantable, like this device, that was a device that was implemented through a biohacker, Tim Cannon, a few years ago. And he decided to tether his very big Cicadia device with a tablet. And all he was looking at was vital signs and statistics. So you could see the reams of data there in the blue screen showing with white records there, and that was recording heart rate, pulse rate, and one additional thing, which was the temperature. Forgive me, just the pulse rate and the temperature on this occasion, I think through the Cicadia device. And then we have an implantable that you can see the top left screen. This is in the arm of Mr. Emil Grafstra, interacting with an external device. So imagine I had an implant there between my thumb and forefinger, and I was using the device to actually interact. And so that's the, I guess, the in-body example there of an operational scenario. But as I said, increasingly, we are all carrying additional devices. Is this what the human body might look like in the future? Here was some work in speculation in 2005 that I completed with Chu. And with him, he was a Singaporean naval officer doing his honours degree at the University of Wollongong. we hypothesized about hierarchical positioning. If somebody was in the Earth's surface, how could we know where they were? And the last mile was, in fact, an RFID potential to be implanted in the human body. Again, I'm not a proponent of this device, but I am being currently seconded to considering small ventures that are starting to begin and to be talking at different kinds of launches, for example, regarding implantable devices. The latest one from the UK with some startups looking at border control. I see the human and social implications of this technology. I'd love to say that, yes, we could all put an implant device in and everything would be fantastic. You know, we'd be able to know when someone was going to get sick. We'd be able to know when someone had a fall down alert. We'd be able to know when someone was speeding and cut their speed in the car. We could know where people were that were in an emergency situation. We could know where COVID was. I mean, there are all these kinds of applications that have begun to be discussed. So Übervalenz. I completed my PhD in 2003, but the concept of the electrophorus, the bearer of light, or the bearer of electricity, came about around about 1997. And already in my thesis, I was talking about, have we really thought about the consequences of going from this tetheredness between the human and a machine to wearing a kind of implant device on the body to actually swallowing devices that were silicon-based or had RFID transmitters. And lo and behold, we did hear in 2019 about devices that were RFID devices, basically so small that could be placed in a tablet that you swallowed for your illness and as a response to, you know, as medicine. And so these transmitters were so small that they would dissolve in the human body, but they would be able to tell us about the behavior of the individual and whether they were taking their medicine on time every day, and whether that was having an effect in the human body. Do look out for that research paper. In 2002, I published something in Internet Commerce that looked at implantable devices and the experiment I had discussed with Professor Kevin Warwick. In 2006, MG Michael defined the term Übervalenz in a class at the University of Wollongong, and it was really about situational awareness and predictive profiling and where this surveillance was all going. And it was all-seeing. It was beyond the all-seeing eye. It was within us. He was discussing embedded surveillance devices before they became a commonplace capability. So the who, the where, and the what condition, the physiology. In 2007, we published a volume, an edited volume, as part of the Secure Research for Australia. And we looked at the concepts going from datavalence to Übervalenz in the transparent society. We looked at concepts of what it would mean to hack the human heart or hack the human brain, and whether this access of access would lead to misinformation, the misinterpretation of data, and information manipulation. And for all of you who are studying data analytics from smart devices, this is one of the biggest shortcomings that we're seeing, not just in social media, but in actual products and devices, in consumer electronics even. Could the fallout of these technologies lead to misinforming or misinformation? Could it lead to a misinterpretation of data? What does the data really mean? Can I manipulate the data? And is that what's happening, as we've seen through political processes like campaigns and elections? And what about information manipulation? What does that mean? What if my data was denoting some kind of predictive element in your behavior, but in fact, you never carried out that behavior? And so we can see big discussions happening here with many big organizations like Palantir about what is happening with predictive data. 2007, MG Michael presented at the Data Protection and Privacy Commissioners Conference in Montreal, where he was asked to talk about Übervalenz. The late Robert Ellis Smith, a privacy journalist and reporter, quickly took on board MG Michael's comments from that particular privacy conference and data protection conference and said, look, we have to look for this whole new technology that's about to come on board. And it's not just Big Brother, but it's Big Brother on the inside looking out. And what are we going to do about the control and data ownership of the information that's emanating from everyday devices? At the same time, Forbes, through Robert Ellis Smith, made a big front page sort of news flash on uberveillance. Here we see a depiction of Jim Nuttall's drawing of uberveillance. And what he's showing here is still that Big Brother is still there. There is always still this notion of surveillance through data analytics. But in fact, we are now increasingly paranoid for those of us who are carrying implantables, and that's about 10% of Americans, according to the NIH, right? They're not all electronic implantables, but they are hip replacements, knee replacements, and so forth. But we are becoming increasingly thinking we are playing to a global theater, that our digital footprint is not just now what we buy and where we go via location, but it's also inside of us. It's how we're feeling. It's our levels of stress. It's our temperature. It's our sickness. It's our level of health. And this is a whole new era. In 2008, the term was entered into the Macquarie Dictionary and also made the New York Times on SHOT's vocab. It was about total and inescapable internal personal surveillance. And here we can talk about the IEEE standard to the body area network, but also this notion of what's a personal area network. In 2009, our first full-length volume, 500 pages, came out on innovative automatic identification and location-based services, from barcodes to chip implants. And what we found was there were increasingly a number of futuristic types of applications. In this instance, we have Emil Grafstra's Vivo Key. The Vivo Key at the time that it was launched, somewhere around 2013, was looking at how we could place an implantable device in the webbing of our thumb and forefinger and use this as a means to enter absolutely anything and transact with the world around us using an encrypted device. And so Mr. Grafstra was thinking about open ticketing. He was thinking about transit ticketing, Bitcoins. You know, what if my handshake was actually a transaction at a bank? What if I carried information that could be unlocked through this secure device in my hand? What if I could transact, I could purchase things, I could do communication with the government, for instance? The term then entered the Oxford Dictionary in 2010, particularly from a legal lens, and it was about ubiquitous or pervasive electronic surveillance that was not only always on, but it was always with you, right? This is transferable. I could leave it behind. I could put it in the boot of my car and let my car be with my husband while he's traveling, okay? But implantable devices, the difference between implants and mobile devices is that the implantable is always with you. I can't leave my heart behind, can I? I can't leave the defibrillator behind, because that might mean I could have a cardiac arrest, okay? So we used to have devices like defibrillators that we would have to cart around with us that were actually in an external trolley device with the defibrillator on the device. It then moved from the trolley to around the neck. I used to wear it with me wherever I went in the 1950s. And finally, it did become implantable because that was the most convenient solution, right? It was protecting the device. It couldn't be tampered with, less chance of infection once something is fully embedded in the body. And so we are starting to see that the traction of this seductive nature of embedded technologies is coming to the fore. In 2010, we also published this Proceedings of the IEEE paper on planetary scale RFID services in the age of uberveillance. I gave a talk on uberveillance in 2012. You can see that on TEDx. At that talk, I talked about how we're going from all of these different modes of operation. And of course, we're going to end up with this scenario being offered to us of implantables. The question is whether society believes the hype around implantables. And for some of us, it's not hype, it's life-sustaining, so we need it. But for others, is the convenience going to outstrip the control nature of microchipping people? And so I want to hover on this standard. You know, many of you might be thinking, what is Katina talking about? What do we talk about when we're saying the last mile, the black box within? We're actually talking about an IEEE standard here, the wide area standard for body area networks, right? Sorry, the wireless body area network standard. That's 802.15.6, and that came into fruition around about 2012. It is about real-time health monitoring, but as you can see there, it's also about consumer electronic applications. Whoa, right? IEEE have defined a standard that is also about implantable devices or wearables in the context of consumer technologies. It's an international standard for low power, short range, and extremely reliable wireless communications within the surrounding area of the human body, supporting a vast range of data rates for different applications. And keep in mind the data rates, because it all has to do with spectrum, okay? We can have all the standards we want, but these wireless devices work on spectrums, okay? It's very important that I describe that. And so in 2013, we came out with the first book titled Übervalence and the Social Implications of Microchip Implants. And that was the time that DARPA was releasing a whole host of procurement tender documents saying, you know, for our ex-servicemen and women who are suffering from post-traumatic stress disorder, maybe we've got to start thinking about implantable devices. Around about the time of the Iraq War, a bit earlier, we also had many servicemen and women coming back from war, missing limbs as a result of landmines. And all of a sudden, we were talking about the potential to have robotics there with control from a computer just by thinking about it. So the human would have an implantable device placed in their brain that would be able to think about something, get into the zone, and actually then they could have a robotic limb opening and closing. Especially for quadriplegics, as we've seen, for example, at Brown's University, we've seen somebody who could not use their limbs after becoming a quadriplegic. Think about requesting a robotic arm to come around and feed them and provide an ability to quench their thirst through the drinking of a water bottle. These are all real applications that we're starting to investigate. And we have some big companies backing the ability to have these implantable devices. So if you think you're not going to be challenged by this notion of implantables in your lifetime, please think again. Companies like Medtronic, this was on the front cover of IEEE Spectrum, have wanted to implant sensors in everyone as a way to prevent perhaps an attack, an acute attack of something like disease. Others have thought about it as a way to look at the vital signs and characteristics over time of the human body and to perhaps use that to enhance somebody, whether it's through physical training or sporting regimes. And still others have thought about this in the context of when someone is having difficulty having a baby, for example. Could temperature monitoring assist somebody not to have to go through different kinds of options for childbirth, and they could simply monitor their own vital signs and characteristics to actually know when the best time was to attempt to have a baby, for example. There are many applications of this. But I do want to state this and underscore this. On the cover of IEEE Spectrum was something talking about an implant sensor in everyone, and how would that change the landscape? NIST considers frequency bands here. You can see that in your own time. We're looking at different applications of this sort of wireless body area network for mixed medical instrumentation devices, for things like ultra wideband, and you can see the different megahertz and gigahertz scales here for different parts of the world. And so when we're looking at a global environment and we're talking about implantables and wireless devices, we simply can't assume that my device, as I traverse the world around me, is going to work the same way. In fact, we've seen incredible scenarios, and here we're just looking at backscatter and propagation. If this place, NIST is speculating, is this where the best place for a hub internal device might well be? But we've also speculated on commercial devices that have nothing to do with medical. Elon Musk's Neuralink, for example, and what may that come forth with. I was giving a talk, a TEDx talk, another one at ASU earlier last year in May. And in this talk, I talked predominantly on brain implants and some of the social implications that this might bring in, especially for data analytics. Brain-to-brain interfaces, can you imagine that? And this year, the case of an edited book by Isabel Peterson and her co-editor, Andrew Iliadis for MIT Press, where MG Michael, Christine Paraxelis, and Roba Abbas and I look at this notion of last mile surveillance. So if you want to see a close to 35-page book chapter dedicated to what I'm talking about, it is this communal book chapter that's been edited with my peers, where we talk about Übervalence in the context of implantables. And so again, to stress here, with limited time to go, this is not just a one-way solution. This is bi-directional between devices. Where does the processing take place? Is it in the implant? Does it happen somewhere in the wireless sphere? Does it happen on a hub device? Does it happen back to base? And this notion of tiny machine learning that's starting to gain momentum. And where are the signals being extracted from and with whose permission? And so there are lots of social implications. Imagine the body was full of nanobots, these tiny micro nano computers that would be going around our body and looking at whether we would perhaps be predisposed to cancer. Is this what we're going to do in the future to the bloodstream? And if so, what does medical data analytics take us to? Will it be going away from the Internet of Things scenario to the Internet of us, our human body? There's an Internet within us. There's a body area network within us. And then, of course, issues to do with electromagnetic interference, issues to do with biohackers wanting to take things into their own hands and saying, corporations, you might think you own my insulin pump and my insulin data, but I've hacked the device, as has been demonstrated here, so that people have better visibility of how the internal implantables are working. Future devices, what do we learn from pacemakers? Corrective firmware updates, they need to be updated. They suffer from attacks, denial of service attacks or distributed denial of service attacks. Here we see an SQL injection, a paper written by Mark Gasson for IEEE ISTAS 10 at the University of Wollongong, showing how malware could infect our data and also our implantables. And some of this is perhaps, I would say, deadly, right? Death by internet, perhaps. So to conclude briefly, the need to be part of the ongoing standards discussion is huge. We need to bring in sociologists, anthropologists, historians, theologians, psychologists, medical people, not just engineers to define a standard. I want to call on this community to basically say 802.15.6 is not complete if we don't get these discussions that are more robust. What does it mean to have an implantable device? What does it mean when we are traversing the world and don't know when something is triggering, for example, an RFID implant to emit signals to it in response, perhaps our unique ID? What happens when other devices are much more powerful and start to tether to our implantables or wearables and starts to do something? And what is the role of the data analyst here? Do they just ignore the privacy, security, ethics, and human rights issues? Or do they become a part of this discussion and think about ways to encrypt the data and perhaps even offer it back to the patient or the citizen who's carrying the implantable device if they so choose to? What will last mile mean in the future? It used to mean to the house. It used to mean to the retail, perhaps shop front. What does last mile mean now? Does last mile mean to my Apple wristwatch, or does it mean internally to some brain implant like Neuralink in the future? Where does the computation happen? Is it going to be closer to the actual device on the body? Who may well be dependent on a body area network? And what happens if we take this notion of black boxes and multiply them? I bring them together. So I have an implantable device that's a black box like the flight recorder, but it's in my brain. And then I layer that with AI and neural networks within the black box. I've almost got this multiplier effect that I just don't have a black box within. I just can't grab with my hands, take it out and put it somewhere and analyze it, right? I've got to have the know-how to get to it. But then I also have the algorithms that we're all building that actually may well not be in our control. What kind of data set will this be in terms of brain? And what does that mean? Does it follow that we now believe in the concept of death by internet? And what about social inclusion, equity, and exclusion? Which upgrade do you have? Which implant do you have? How does it work with the outside world? Can you go for a job interview at the same time I can, if there are all of these things happening? And I pertain to the last thing, which is perhaps the most important, bodily integrity laws that don't exist in the world. How do I maintain ownership of myself and of my data? We've already lost it through Google, through the searches that we perform. Now what's going to happen when we're starting to look at Katina's heart rate, Katina's perhaps sensitive areas suffering from disease, Katina's thoughts, which I don't think we're going to get to, but perhaps more precisely, Katina's state of her heart? Will I be insurable if the doctor or the insurance company knows what I'm swallowing, and perhaps I'm not doing enough exercise, lending itself more to control. So with that, I hope you found the presentation entertaining. We've got about 10 minutes for questions, and I'll hand back to our panelists. Thank you very much for your time.
Thank you, ma'am. Dr. Katina Michael, I thank you from the bottom of my heart for your nice presentation and valuable information given for all participants by expanding your valuable time for whom would like to work on data analytics. Also, I'd like to thank for all participants for utilizing this wonderful opportunity. Dear participant, you can post your questions in question answer. Otherwise, you can raise your hand. I will unmute you, then you could ask. Dear participants, you can post your question in question answer chat box so that none will answer to your questions. Or otherwise, raise your hand. I will unmute you, then you can ask.
Yeah, ma'am. Am I audible, ma'am?
Yes, sir.
Ma'am, this is Surya, ma'am. I am the one of the organizers of this conference. Ma'am, there is a one question in Q&A. Shall I read that, ma'am?
Yes, sir, because I actually have flipped to a view that I can't see it. So please do.
Yeah.
Thank you.
Yeah. I'll read out. Is there any possibilities of spotting virus like COVID-19?
Very good question. I think we are already starting to see projects like that between Stanford University and the Fitbit. Let's call them Google for now, although they're in the process of buying. And in this study at Stanford, what they have requested as a response to COVID is, why don't we look at whether wireless devices that we carry, like the Fitbit, that does take all those vital signs and characteristics, if I contribute all my data, whether in fact I can allow for the early intervention. Because I see in a society, if we all wore Fitbits, for example, we all wore the Fitbit device and we all gave our data to our government or our medical health insurance companies, and they could see, Katina and her son and her cousin and the work colleague, they're starting to come down with something, some disease. Let's call it COVID. Perhaps there is something going wrong. They've all visited the doctor in the last couple of weeks. So what we are seeing is this predictive element. The question is, with infections, we are told that about 80% only, 80% of infections are mild or asymptomatic. That is, the person feels completely normal while they are carrying COVID. So if I am completely feeling healthy, but I'm a carrier of this ugly disease, this pandemic, and I'm going around my business, I don't realize I'm sick. My Fitbit is not really telling the health insurer anything because I'm feeling fine, but I'm a carrier. And so this is where ubervalence comes into contact. Remember, I talked about misinformation, information manipulation, and misrepresentation. So the Fitbit thinks I'm fine, but in actual fact, I'm a carrier and I'm spreading disease to everyone around me, which is why the governments across the world have said self-isolate, quarantine, go into lockdown until we get this COVID-19 under control. So I'm not saying predictive analytics is not good, because as data scientists, right, all of you who are at this conference are thinking about all the wonderful things you can do with big data, for instance. If we just had the data, we could do X and Y, but we run the risk of the predictive analytics falling short. And let me show you this in the way we are looking at policing. For example, if my data set is being trained on Black Americans or Black British people, it may well have bias embedded in the actual algorithm in the black box. And so every time the camera sees this kind of activity, it is a Black ethnic minority that is the one who is the suspect. And yes, we've got the suspect. Okay, we put him behind bars or her. And so in the same way, we can say that if we were to use these Fitbits or implantables that were constantly sending information back to our medical health insurers, quite possibly what we are saying is that we will find ourselves in the same mess. Either we will have panic for nothing, or we will not be actually panicking enough. We will not be responding enough to something. But I do sense that we are going to be using more and more technology to combat COVID-19. We are already seeing swarm intelligence through drones, and many of you will be working on the data analytics for these autonomous systems as they roam. Others will be looking at Fitbit and, you know, the Stanford University kind of approach, which is give us your Fitbit data and we'll tell you whether you're sick or not. In fact, is this a replacement for a COVID test? So currently there are not enough COVID test kits to go around. And so many universities are speculating, should we be looking at AI and data analytics to tell us whether someone is a sufferer? But again, I go back to, what if someone is asymptomatic? They look completely healthy, but they are the ones actually spreading the disease. So it's very interesting, my friend. The other thing is there's been a lot of conspiracy theory, of course, over vaccines and whether they will be relayed out as vaccines with implantable devices that show somebody to be a carrier. I don't believe this conspiracy theory. I don't think this is going to happen. Until I hear otherwise, you know, I will let you know. But a lot of people are speculating. Imagine you had this kind of capability where you could implant someone, have a vaccine, and then that could act as a digital hygiene certificate. So the carrier who has had COVID in the past, won't get it again, or has been inoculated against it, but has taken a vaccine, they can roam the globe with this digital hygiene certificate. But it's a very interesting concept, but one that I don't think the world is ready for at the moment. We just want to find a vaccine for now. So I liked your question, by the way, whoever asked it. It's an invaluable question for right now.
Thank you, Professor Katina. This is Dr. Bhanu Prakash.
Hello, Dr. Bhanu.
We do have a lab related to microwave antennas and body area networks. So we would like you to help us for collaborative research with our department. So like even we expect like, please kindly accept our invitation for adjudicator, like thesis examiner. Like in fact, Surya Kiran, who is the host, is actually working on deep learning. There are some other scholars also working in deep learning and data analytics. So I think you can help us for a thesis examiner as well. And one other thing is, I think I met your husband from University of Wollongong. Yeah, a few years back in international conference. So he gave your card actually. Yeah,
that's generous of him. So Dr. Bhanu, he was very taken with all of you and the hospitality you showed towards him. I thank you so much. Thank you. I remember he was telling me about the special lunch he had with your team, but also the students. He came back boasting about how eager they were to learn and to listen and to act. I think you have a wonderful establishment there at KL University, and Dr. Bhanu, congratulations for putting this event on. Very well organized, my friend, and to better and bigger things in the future. Congratulations.
Thank you. Thank you very much. We look forward for a collaborative research.
Thank you.
Thank you. Thank you.
Ma'am, there are two more questions. Can I ask?
Of course, yes.
Yeah. The second question is like, does the posture of human body affect the MAC layer with respect to data transmission?
Yes, it does. The water is made up of, the body is made up predominantly of water, which is one reason we can't have GPS devices implanted in our bodies, right? For navigation, they have to be outside. So the body acts as a barrier to a lot of interaction. But what we're finding increasingly is that a lot of experiments are being done on where to place sensors in the body, how far away to place them. For example, brain pacemakers require the bilateral implants to go into the brain, but the actual battery pack is in the chest, here in the clavicles. And so there is a wire that travels up the neck into the brain. And that wire currently is not twisted pair and should be, because it is lending itself to a lot of electromagnetic interference. But what a lot of people are starting to study is how can we get the battery smaller, and how can we get it in the brain co-located with the implantable device? The same thing with the heart pacemaker. But when we are talking about hubs, where should the hub be? You know, I used to see a lot of different patents. If you go to uspto.gov and you start searching on wearable hubs, implantable devices, and spend many months looking at these patents. I remember an early one saying it should be at the top of the head because the top of the head had line of sight to satellites or was not interrupted by any part anywhere else, right? So if we put it lower down towards our tummy, there is a lot of backscatter and a lot of issue with propagation. It doesn't always work. And this we have seen with the COVID-19 applications with Bluetooth low energy being used in the smartphones, actually not working to send an anonymous identifier to another handset. So this has been a very interesting experiment with COVID-19, but in terms of where do you put it in the body, there are optimal places. Others had a pack here on the side of the arm. In the old days, there used to be fat packs. But this is the question, you know, what are we going to look like in the future? This is also an issue we should be thinking about as computational people. It's not just about the data or the smart devices, but are we going to change the way we look? Is it going to be smart glasses that we all carry as we're going around looking at the world around us? On the one hand, the internet streaming transaction, you know, and on the other, we can see the world. I don't know. I don't know. I hope we become and stay as natural as possible. And the last question there.
The next question is like, how to identify whether microchip is malfunctioning or not?
Yeah, great question. I guess we talk about this all the time. In some of the terms and conditions, for example, in the Google Glass, if you were one of the first 1,800 people to sign up about Glass, right, the Google glasses that would stream the internet and record around you if you wanted to, there was somewhere in the terms and conditions that the supplier had the right to switch off. This is the right to remove your capability of actually using the Google Glass, perhaps inappropriately. But I want to go to those terms and conditions because the user will be at the mercy of those terms and conditions in the future. So if the corporation has the right to switch off, perhaps I have the right to switch off your heart pacemaker. I have the right to switch off your diabetic pump. You know, what else are we going to have the right to do? Perhaps I use an access control matrix, and this goes back to M.G. Michael's definition of access, as in accessibility. So the access, AXIS, of accessing something, accessibility. Imagine I had the right to control you. I was your government, I was your medical health insurer, I was your bank, I was your telecommunications provider. And maybe I know the device is malfunctioning when I lose service completely. I don't have access. It's a loss of control. There's a denial of service attack. Oops, I can't access my Bitcoin or my blockchain. I don't exist on the blockchain for that 24 hours that I'm not a person because everything is centralized through this last mile implantable device. What happens, for example, when I'm locked out of funds? I'm locked out of my front door. You know, someone changes the locks. I'm locked out of my telephone for communications. Perhaps in the future, that's a brain-to-brain message being sent to people. So we find out about malfunctions when there's a complete loss of service or when there's something going wrong, like a stranger has access to my front doorstep, if I have everything electrified in my home. It's a fantastic question. I know in the case of one deep brain stimulation recipient, Gary Olift, from the former, he was a former professor and actually a professor emeritus at the Colorado School of Mines, studying remote sensing and electromagnetics. I know from him that it was instantaneous, right? So he has a deep brain stimulator. He went to a Best Buy store that sold electronics, and immediately his DBS was tripped by the actual wireless environment he was working within. So he can't go to libraries. He can't actually not only frequent libraries, but also go through shopping malls. He can't drive his car. His car has 8 computers. Even Wi-Fi affects the DBS. So it's very interesting for us to see, when do you know it's malfunction, when it doesn't work, when you feel terrible, when you feel sick, or you don't have access.
That's wonderful. We have questions from YouTube Live also. We will do one thing. We will just consolidate all questions and send across your mail.
Okay.
Yeah. Thank you so much. Thank you.
Thank you very much for your time.
Dear participants, the next keynote will be at 4 p.m. Dear all participants, the next keynote address is at 4 p.m.
Hello, can you hear me?
Yes, sir. Yes, sir. You are audible.
Yes,
You can also check your video test.
Sure, of course.
You can turn on your video.
Yeah, sure. Good afternoon. I think my webcam is also activated now.
Yes. Your video
Yes.
is fine.
Yes, it's great.
If you want, you can just test your PPT, share your PPT, if it is working or not. We will start sharply at 4 o'clock.
Yeah, sure. The button for sharing seems deactivated for now.
Sir, exactly at 4 o'clock, I'll give you presenter access, sir. Yeah. So once your introduction is over, then you can start your presentation.
The screen sharing button seems passive for now.
Yes, sir. I have to give presenter access, sir. Yeah.
Okay, sir, it's fine. After 10 minutes, we will start your session. Okay. Thank you.
Okay. No problem. Thank you.
Now you can check, sir.
I think you can see my screen now, and the presentation is visible.
Yes, sir. It's perfectly visible. Yeah.
Okay. I'm now closing it, and let's start in 10 minutes.
Sure, sir. Sure.
Okay.
Hello, everybody. Good evening to all of you. I welcome you all to the live session of address by Utku Kose. Hello, sir. Good evening, sir. Utku Kose, sir.
Hello, good evening.
Sir, first I would like to give a small introduction about you to our participants.
Of course, sure.
Yeah, once it is done, then you can start your presentation, sir.
Okay, thank you very much, dear Professor Yalla. You can introduce me, and after that, I will start the show.
Yeah, fine, sir. Yeah. Yes, please. Here comes the resume of biodata of Dr. Utku Kose. Dr. Utku Kose received the BS degree in 2008 from Computer Education of Gazi University, Turkey, as a faculty valedictorian. He received MS degree in 2010 from Afyu Kocatepe University, Turkey, in the field of computer, and DS PhD degree in 2017 from Selçuk University, Turkey, in the field of computer engineering. Between 2009 and 2011, he has worked as research assistant in Afyon Kocatepe University. Following, he has also worked as a lecturer and vocational school vice director in Afyon Kocatepe University between 2011 and 2012. As a lecturer and research center director in Isaac University between 2012 and 2017, and as an assistant professor in Süleyman Demirel University between 17 and 19. Currently, he is an associate professor in Süleyman Demirel University, Turkey, and he has more than 100 publications, including articles, authored and edited books, proceedings, and several reports. He is also an editorial board of many scientific journals and serves as one of the editors of the Biomedical and Robotics Healthcare book series by CRC Press. His research interest includes artificial intelligence, machine ethics, artificial intelligence safety, optimization, the chaos theory, distance education e-learning, computer education, and computer science. So that's a wonderful resume, sir. So we would like to invite you to the international conference. Yeah, please start your presentation, sir. Thank you.
Okay. Thank you very much, dear Professor Yalla. Thanks for everybody for joining that session, and I would like to congratulate everybody for realizing the International Conference on Intelligent and Smart Computing in Data Analytics 2020, and also I would like to congratulate the KL University and the Department of Computer Science and Engineering for realizing that event. And as the professor has introduced me, I'm an associate professor at the Department of Computer Engineering at Süleyman Demirel University in Turkey. And my presentation is especially based on the new concepts of AI, and also focusing more on the XAI, which is we are calling as the explainable AI. I'm just sharing my screen, so you will be able to see my presentation. Yes, I think there is no problem. My presentation is called as the new concepts of AI and XAI. Briefly, I will just introduce something and give some essential information about some new concepts of AI. I think the majority of the listeners are being aware of such new concepts, but I will just direct my presentation to XAI after introducing some of new concepts. And after that, I will just try to give some essential knowledge about how we use XAI, explainable AI, and why we need that new concept for the future of artificial intelligence. Yes, my presentation will be start with a brief introduction to the concept of AI, to the field of AI. And after that, I will talk about some soft fields and some techniques of the field of AI. And after that, I will just talk about some present problems which we are using the AI for providing some effective solutions for them. And after that, I will talk about some new concepts of AI, and I will direct my presentation to the XAI. I will try to explain the details of the XAI. Of course, that's a very deep topic and a very trendy topic for now, and a new topic, especially for the literature of AI. But after my presentation, I think most of the listeners will be able to have the necessary knowledge to direct their research to that new concepts of the field of AI. And after that, of course, I will just give some suggestions and some points to inform you about further things to do in the context of AI and XAI. And after that, at the end of my presentation, I will take your questions. Here, Professor Yala has just introduced me, so I will pass that slide. You can visit my academic profiles and my personal website to be informed more about me, more about my research works, and also more about my some blog posts. So you are all welcome to visit my profiles. I'm, as you can see and as you have just learned, I'm living in Turkey, living in Sparta, the city of Sparta, and working at the Süleyman Demirel University in that city. I performed my Bachelor of Science at the Gazi University, located in Ankara, the capital city of Turkey. And after that, I moved to Afyonkarahisar, which is my hometown, especially. And after performing my Master of Science, I've also completed my PhD at the Konya city, as you can see in the east side of Afyon. And after that, in 2017, I moved to Sparta city as the assistant professor. And starting from 2019, I have appointed as an associate professor. And for now, I'm working at the Department of Computer Engineering in the Süleyman Demirel University. And we will all see if I will move to another city or another country or another place. But as you can see, I'm just performing my academic career around this region, these cities, and you are all welcome to visit Turkey, and also especially Sparta and my hometown, Afyonkarahisar. We are famous with our historical place in the independence war of Turkey with as the city of Afyonkarahisar, and there are lots of historical places and a very big castle in the middle of the city, and you can visit Afyonkarahisar to see many historical places. And calling the city of Sparta, we are famous with the roses and with the lakes. Because of that, there's a region called as the region of lakes, and there are lots of green areas here, forests and green areas. So you are all welcome to visit both cities, and of course visit many beautiful cities of Turkey. And I'd like to also talk about my university and my department. As you can see, the Süleyman Demirel University was established in 1992, and it's a public university with around 70,000 students. And it's very famous with its programs in agricultural research, medicine, engineering, and also business science. And as you can see, there is the logo of rose, because the city of Sparta is famous with the rose. And the Süleyman Demirel was born in Sparta, and he is one of the former presidents of the Turkish Republic. Republic of Turkey, so his name appears over that public university. And our department hosts 3 professors and 2 associate professors, as I'm one of them. And we also have 8 assistant professors with 2 research assistants. And we have 3 different areas of computer science, computer software, and computer hardware in the Department of the Computer Engineering. We have Bachelor of Science, Master of Science, and also, of course, PhD degrees. We also host many international students here, so you are all welcome to visit the Department of Computer Engineering and also our university, Süleyman Demirel University. And let's start after that brief introduction. I will just give some brief information regarding AI. Of course, many of listeners have been knowing enough about what is AI and what is the field of AI, but I will just start from the essentials and move towards the new concepts and also XAI. And when we call the concept of AI, we know Professor John McCarthy, who is the father of that concept, and he just briefly calls that concept as the science and engineering of making intelligent machines. And there are, of course, many different definitions in the literature, as you know, but when we want to make something brief and provide a brief definition, we can recall Professor McCarthy and his great definition. And when we deep into the concept of AI and the field of AI by considering the past, its past, nowadays, present, and the potential future, we can say that it's somehow a simulation of humans, animals, and nature by using some algorithmic techniques. And also there is the mathematical and logical background on of all of these algorithms, as you know. And it's called as a multidisciplinary science because we do not know any field where the field of AI is not applied. When we talk about the end of 19th, maybe we can be talking about some of fields, a few fields where the AI is not applied. But after the start of the 21st century and the many rapid developments in terms of hardware and software science, combining under the umbrella of the computer science, we can just say that there is no field where AI is not applied. So it's a multidisciplinary science. It's also enables also an interdisciplinary perspective to solve real-world problems. So we can say that it's the science of the present and, of course, the future, because it provides effectiveness and efficiency in real-world problems. So we just use it for especially raising some technology-based intelligence solutions. And it's already enrolled in the daily life, as you know, in our cell phones, in every places surrounding us. So some of new concepts also are rising. So my presentation is just includes these concepts and very remarkable concepts, XAI. Because we talk about the future of the AI, we should be asking that if it's an utopia or dystopia, or if it's a technological risk, is it safe or not? And also we can talk about if it's a science without human or a science evolving by its own efforts. But we can say that it's not a stoppable technology and it's not evolving by its own efforts because it's a multidisciplinary science. It's affected by many different fields like electronics or other fields like communication technologies maybe, and also data science, of course. And we can say that it's a science, it's not a science without human because it's a product by the humankind. So we will be all responsible for the future of the AI and for the rise of the new concepts and the way of the safety in the field of AI. And by recalling the XAI, which I will just introduce you in my that presentation, that speech, the XAI is just a need for raising some or developing some safe intelligence systems, which can be used as somehow intelligence systems which can be interpretable, which means we understand how they have achieved their outputs and how they are safe or not for solving the real world problems. And that's a need because, as I've said before, the field of AI is a multidisciplinary science. It's all enrolled with communication technologies, with electronics, It's also a great relation with the data mining by considering the data science and of course considering the statistics. We can say that the concept of data science is just a new name and a new evolved name for calling the statistics or recalling the statistics, of course. And there is the logic, there is the mathematics and the background of the AI. So because of the role of the electronics and computer science, it has a great relation with robotics, and also it has a great relation with medical, and by considering the connection with the nature, we can be talking about the cybernetics, of course. And as like we are doing as the humans, while we are studying for something, we just receive some support from professors or from books or from some different sources to reduce the complexity level of the knowledge to be gained. So we just use some pre-processing of information to be understanding something better. And like that, the data processing is a great supportive field for the field of AI, and we use image processing or signal processing, as you know. So there is a great of complex level with the different fields and the AI. And of course, a more or a wider view of that schema can be provided, but I've just provided something like that. So we can say that it's a very big multidisciplinary science, and the AI tends to be a great the science of the future by having a great relation with such different fields. And when we call the AI, or when we talk about the field of AI, we should be, of course, talking about machine learning and, of course, deep learning after the start of the 21st century, especially. Because the AI and algorithms or techniques under that field of AI can be divided into two main groups. One of them is called as somehow algorithms which can be learning somehow about the target problem, and the other group is called as algorithms which do not need learning phases, for example. And when we have somehow an official name for the algorithms or techniques which can be learning about the target problem, we can use the name of the machine learning. Of course, that doesn't mean the algorithms or techniques who or which do not require learning phases are better than the machine learning. That means you just have the responsible to decide which type of problem to be solved and which type of algorithms or problem modeling site you will be following, because some problems need somehow some pre-training about providing new solutions for newly encountered versions. For example, in the future, we just use machine learning. But for some problems, you just use some mathematical models. And of course, in that way, you just use some iterations or iterative algorithms to reach to some results, which tends to be maybe heuristic, for example, or which tends to be not with a 100% success, but at least somehow some accurate results, maybe tending to some percentage between 80 and leading to maybe 98, maybe, but not a 100 of percentage at total. And when we call the deep learning, we can say that it's the new version and new advanced form of the machine learning after the start of the 21st century. Of course, there were some different efforts during the 20th century, but because of the hardware requirements and computational lack of the computational resources, the rise of deep learning, or that name, was not used during the 20th century. But after the start of the 21st century, the costs regarding especially hardware components has decreased or started to be decreased. So it was more possible to use more advanced form of different machine learning techniques and of course neural networks. And we just call that formation of the neural networks, advanced neural networks, as deep learning, which means using or analyzing the data deeper to reach more accurate and successful results for especially problems with complex and big data. And when we talk about some subfields, of course, I talk about machine learning and deep learning. I've just talked about them, but we should be talking about optimization maybe because I've just talked about some algorithms or techniques which do not require some training phases before. And such algorithms or techniques are called as under optimization, for example, and also rule-based techniques sometimes. And when you talk about optimization, you should be talking about mathematical modeling of the target problems, and we can be talking about evolutionary algorithms or nature-inspired algorithms. So they are somehow different versions of the techniques which do not require learning or training phases. And of course, we can be talking about cybernetics, which just provides some electromechanics solutions or maybe electrobiological solutions in the near future, maybe to solve some problems of especially living organisms like supporting humans with lost organs by using some electromechanical robotic systems maybe, and also providing somehow some improvements regarding your some abilities like using some spatial lenses to have night seeing or night vision ability, for example. So that's the subfield of cybernetics under the field of AI. And also we should be talking about associated technologies, of course, some smart tools like IoT or maybe other technologies in different fields, maybe just smart tutoring software systems in the context of education, but we can just have that associated technologies or techniques sites under the field of AI, so we can just have somehow a way to make the connection between different fields and the field of AI. And I'll just talk briefly about machine learning and some essential information which I think many of our listeners may be knowing, but by targeting especially, of course, our friends, students, I've just included some additional slides in order to be providing some essential information. So when we talk about machine learning or deep learning, we should be talking about training, testing, and application phases, which means like as the humans, we are reading some books, listening to some lectures, joining to schools to be learning something enough about the target problems or targets concepts of the real world. After that, we just try to pass some examinations like we are doing at the schools, at the universities, or during lifelong learning maybe. And after we pass the examinations, we just promote to a job or maybe graduate from a degree. So that's very similar in the machine learning, but we just apply some analytical and algorithmic steps to perform such things. And we need some data to perform some training, some already known past states maybe, or instant feedbacks, like talking about reinforcement learning, and maybe somehow some clustering methods to have some predicted outputs or grouping for the past known data, and so that we just train our target system like neural network or decision tree. And after that, we apply some testing by using some data which we have not showed to the technique during the training phase, but we already know about the results, their outcomes. So after passing that or that testing phase, our system can be then applied in real manner in real applications. But of course, there are many different problems. For example, we should be carefully modeling the target problem, and we should be dealing with training issues like deciding which parameters will be enough or will be effective to reach to a good results at the end, or maybe which training the parameters should be used for preventing from overfitting, like we are just knowing something about some pages we are reading from the books, but we don't know about or we don't know enough about logic on the background of the target problem. So we pass the examinations, but we fail during the real application. So we should be carefully dealing with such problems. Of course, that takes us to deciding to which techniques to be applied and which parameters to be used. And these are just another topic for another presentation, maybe in the future. So I am passing that. But when we talk about machine learning, we should be talking about the artificial neural networks, which are very famous machine learning techniques. There are different types of machine learning techniques, but artificial neural network is maybe the most famous one and the most maybe successful ones in the history of the AI. So artificial neural network just gives us enough information about how to simulate the working mechanism of the biological neuron cells and also the working mechanism of the brain. And by just using some weighted data through to that model of, the, for example, multi-perceptron or multi-layer based perceptron model, by just using that model, that artificial neuron cell model, which we also call as the perceptron, we just try to optimize weight values to reach to to reach to a trained model of artificial neural network. So after training or after optimizing that weights according to some past known data, we then just use the artificial neural network model to give some inputs about newly encountered problems to reach to some predicted values or predicted classification values or real number values or other different types of data to have some decision support by such model. And when we talk about deep learning, we should be saying that the machine learning has been just transformed into a new type of problem solution, which includes deeper analysis regarding the data. And for example, when we talk about that the classification of that things, we just be talking about the data processing. That was a need for the machine learning because we just filter or we just make the data more ready for understanding about the target data. But when we come to a traditional machine learning technique, we can be failing for some real world advanced problems, including complex and big amount of data. But by just using deep learning techniques, we have the opportunity to run some feature extraction phases inside that advanced forms of neural networks models. Of course, you are all free to use some additional feature extraction techniques, or you may be manually editing some data as the human before passing to deep learning. But simply deep learning techniques, especially CNN or maybe deep neural network models or maybe deep leaf networks, enable you not to use feature extraction so that you can just feed your input data to be training your advanced neural network model and to be reach a trained system which is able to predict something about the target problem, which is more complex and requiring more amount of data. And by talking out of the machine learning, we can also be talking about some different, for example, rule-based techniques like or control-based techniques like fuzzy logic, for example. That's not a machine learning technique, but it's very effective in solving real-world problems requiring control-based decision-making for especially the field of electronics, maybe. It's just uses the fuzzy logic theory, which is provided by the Professor Lutfi Askerzadeh from Azerbaijan. And it's just different from the crisp logic. It just says that something has different membership and it's not just has two different memberships like 1 and 0, but it's just have some real numbers changing according to membership levels to the different types of groups. So we just use fuzzy logic to solve real world problems which have more fuzzy logic on the background, not a crisp logic like the computers are doing. In even computers, we just manipulate some data processing steps so that we just receive something like we are using in a real-time manner, but it's somehow a logic strategy. but in real manners, computers just used 0 and 1, except from quantum computers for now, especially. But when we use the fuzzy logic, we just apply the real human-based decision reasoning or decision making to the already known digital-based systems like computer-based systems. And when we talk about optimization, we may be talking about genetic algorithms. For example, you just use some essentials of the theory of evolution to run some optimization steps to be knowing somehow unknown variable values for the target real-world problem, which is modeled mathematically in the context of the optimization. And of course, the machine learning is just optimization. The life is actually somehow an optimization, but the complexity level differs. So you should be having enough idea about what is the swarm intelligence or what is the intelligent optimization, what is the genetic algorithm. So I'd like to just give some essential information about that. By using some essentials of evolution theory, you just use some particles to pass them through some fitness function, which is the model of your target problem. And by just using some iteration-based steps, which is not like a machine learning, of course, because the intelligent optimization is not machine learning, you just apply some evaluation operations like crossover and also maybe mutation. And by just using the most successful particles, you just try to reach to somehow heuristic predicted values for your target unknown variables under the target problem mathematical model. And that's all. And by just using them, we currently just use or run some problems throughout the field of AI, like pattern recognition or like prediction, like information discovery, like vaccine discovery, for example, for the COVID-19 or different diseases. And also by talking about the fuzzy logic or control-based, rule-based systems, we just run adaptive control solutions for such problems. And of course, we run optimization. And of course, there are many different problem solution sites, but combining them under the most essential and the most top level groups, we can just talk about 5 different groups by talking about AI and its applications in present problems. And as I've said before, you may just using pre-processing steps, or by just using deep learning, you may not be using feature extraction. But at the end, you need to test your system. And by using the application, you may be using your machine learning or deep learning techniques directly or indirectly for reaching the solutions for somehow real-world problems. And that's all. Let's move with the new concepts of AI. By just talking about everything in my previous slides, we just be calling that all of these things are just the concept of AI. But for most of scientists for now, we just call the artificial intelligence as a narrow intelligence, which we call as just briefly ANI. That means that such algorithms I've just talked about just execute some specific focused tasks without able to self-expand functionality. So it can be, or such algorithms or systems can be outperforming humans in specific repetitive or specific jobs in routines. So like driving or medical diagnosis or giving financial advice or having decision support at the end. And because of that, jobs can be improved, of course, but such techniques are still in narrow level, which means weak artificial intelligence, for example. So the scientists says that about 2040, and starting from that point, we will be reaching to more advanced forms of new concepts of AI, like, for example, AGI, Artificial General Intelligence. It's just somehow a time period requiring more computational resources in terms of hardware and in terms of course, software. And by when we reach to a desired level and by a predicted year, of course, 2040, we will be able to use more advanced forms of intelligence systems which can be performing broad tasks reasoning and improve capabilities by itself as comparable to us, of course. And at this point, we can say that the jobs will be at risk, of course. And such systems will be, for example, able to compete with humans in all fields, including, for example, earning even university degree by itself and convincing humans that it is human actually. And we call that the level of artificial intelligence and new concepts of as AGI. And after that, soon after AGI, as the introduced by Professor Nick Bostrom from University of Oxford, there is the artificial super intelligence. It's just a more advanced form of the artificial general intelligence. It's just a sign that the humanity is at risk and it outperforms humans, helping to achieve social objectives or threatening the human race at the final. So it demonstrates intelligence beyond human capabilities, we can say that. And these are just new concepts of AI, some of new concepts of AI. And these are just predictions, of course, but we will all see what the next years will be bringing us. And when we talk about more about artificial general intelligence, we can say that it will be having some time by time evolving time periods and evolving improvements in time, which means we will be passing through some weak AI and reaching to somehow some normal level and strong level AI, which leads us or takes us to the new concept of AGI. So that's just the time period we should be just having idea about. And of course, it will be able to understand abstract concepts. It will be able to have emotions, but we will all see because we, as the humans, we have no enough idea about how to model emotions, for example. But these are all just theories and predictions for the AGI. And it will be able to tell right from wrong or be creative like children and explain why. And that will be bring us to explainable AI in the next slides, of course. But the level of AGI includes the everything we have for now for the AI and more things as additional as an improved level of AI. And when we talk about IoT, for example, we can be talking about a new concept of ambient intelligence. Actually, ambient intelligence is not a very new concept, but when we talk about the rise of the IoT and its evolving states, like we are just calling, for example, IoHT in terms of healthcare things, industrial IoT, for example, and that's the sign that the IoT is evolving and more considered day by day in different fields. And by making that IoT as a very common thing in our daily life, we should be talking about the new concept of AI, which is called that ambient intelligence. Ambient intelligence is just somehow a concept that's explaining us that we will be all surrounding by different sensors or different intelligence systems, and we will have no responsible to control them, at least if we are not engineers of them or experts who are building them. But as a normal human being, we will be all surrounded by such things, and they will be all controlling our life for a good life. At least we hope like that, but we will all see if the future will be somehow a utopia or dystopia by the AI. But we will be all responsible for that, as I have said at the start of my presentation. And when we come to XAI, XAI is just a new concept which is currently very trendy and very timely contribution for the field of AI. Because when we use the narrow artificial intelligence or simply when we use the current techniques, we don't know any enough idea about why such a technique, for example, give us a decision or recommendation. Why did you do that? Or why not something else that the technique is providing to us? We cannot ask such questions for the current techniques, for majority of current techniques, including especially deep learning and also maybe multi-layer perceptron, for example. So we cannot be trusting to the technique because we don't have enough idea about how the system has reached to its decisions at the final. Is it as a chance or not? We don't have enough idea about that trust level for the current techniques. So we cannot have enough idea about how we can correct any error appeared in such technique, for example. And we don't know any idea about when such techniques or such intelligence system will be failing. So we will be able to have some precautions to eliminate some failing scenarios, for example. So the scientists have just talked about solving such problems, and they reached to a new concept of XAI, which we call as explainable AI. Explainable AI is just simply an addition to the known current models by using some layers or some modular techniques, some maybe analytical or logical or mathematically advanced algorithms to have some feedback from the numbers going through the technique, so we can ask that, so we can reach that, we understand why that system has reached to such a solution, and so that we can be trusting to any intelligence system using the explainable framework or explainable interface for making us, for enabling the humans to be understanding enough about its decisions and the connection between inputs and the outputs. And when we talk about explainable AI, we should be know that we need an interpretable technique or interpretability aspects of the used techniques, changing from decision support vector machines to decision trees to neural networks to Bayesian systems, blah blah. Many different techniques have many different algorithmic nature. So we should be catching the exact point of the interpretability. So we can be achieving that by extending now AI models to reach to the area of explainable AI. We should be trusting to the intelligence systems for the future, for the present, without having any anxieties regarding their solutions and decision making. So explainable AI is a very trendy topic for especially deep learning, for example, which we have more bigger advanced forms of intelligence systems which have hyper parameters, for example, big numbers of parameters flying around. So we should be having some support, some additional support to be enough idea about why they are acting like that, how their outputs are not because of overfitting or other things caused by different things, not very trustable, for example. So that's the way of the XAI. When we take a look at the literature of the XAI, we can see that starting from 2012 and also using the exact term of explainable AI starting from 3 years ago, we can see that there are many numbers of publications in the literature. So that's a very trendy topic. So I'd like to request everybody enrolled in AI to be having researching or searching something about that field, so providing valuable contributions to the literature of AI. And of course, that's not a very simple way to make your systems explainable because there are many different things to be considered. For example, details of the problems, reasons to be explaining the outputs, and transparency level of each of your algorithms, because, for example, fuzzy logic has just rules, so you can have some decisions or some explanations from the level of the activated rules, for example. But by using deep learning, like CNN, for example, you are not very able to have some interpretations or some explanations regarding the connection between input and the output. It has a more complexity level. And you should be thinking about the scope, because a medical staff or physician or doctor may be requiring something more in detail to be trusting to an intelligence system. But when you use a robotic system in, for example, factory, you may be just using some simple parameters connected with the machine. So your task to be providing an XAI may be simpler according to a hospital, for example. So the scope is very important. And also we reach to human-computer interaction, which means you should be carefully designing the interface to be explaining everything carefully to the human, because different colors means different psychological things, and different levels of texts or other visual components means different things. So you should be connecting enough relations between the mathematical side and the human-computer interaction side, so that you can be, or your intelligence system can be explaining everything enough to the user at the end. And the way of XAI is just for now, at least for the current developments in the literature, we just have somehow two ways to reach to XAI level. For example, we have just some transparent techniques, which means we can be reaching to some parameters while using towards some problems. Like, for example, Bayesian networks, for example, or Bayesian reasoning, you may be just using some probability levels to explain your outputs, or explain the outputs by the intelligence system, or by just using rule-based systems, because they are somehow transparent techniques. You can be just using the input and output connection throughout the rules, and by using each of rules, you can be explaining why your system has just reached to that output, for example. But when we reach to, for example, multi-layer neural networks or support vector machines, and when the more critical way, when we reach to deep learning techniques, they are just known as opaque or black box techniques, which means you should be diving into the technique to reach to some parameters, or you should be eliminating some hyperparameters, and you should be using additional models or algorithms to be having explainable or viewing the explainable side, which is hidden under very different types of numbers or different complex levels inside the technique. So you should be deciding which way to be used for XAI. But of course, when you use an hybrid model, for example, you may be requiring both of sides. So that opens some different types of techniques to be reaching to explanation. For example, when we talk about transparent techniques, you just have three ways to be following: simulatability, decomposability, or algorithmic transparency. Algorithmic transparency means for especially rule-based systems, for example, you just use somehow some decisions or some number values depending in the way of the rules in order to reach to the explanation. For example, by using like the x2 is higher than, for example, 180, and because of that value, the rule 1 is just activated. So by using that, our system has just reached to that decision by making connection to that input, for example. So that's an explanation. And when you use the decomposability, you just try to use some weights or some additional parameters, and you have some additional efforts to having more idea from rules or other things coming from inside of the algorithm to build up some explanation interface before reaching to the explanation at the end. And when you think about simulatability, you can be again just use some rule-based decisions to explain somehow the inputs and its connections with the output. And by using all of them, for especially, for example, black box or opaque techniques, you may be using different ways to be reaching to explanation interface, like visualization, for example. I will show some of samples in the next slides, or just using model simplification by using additional algorithms, you just reach to explanation level. Or maybe just using some text explanation, like the output for x1 is Y1 because X3, for example, is higher than that value, for example, like by just using somehow additional efforts to like building up somehow a layer between the model and the explanation side. And maybe you can be use some examples by using data and data to be explaining the output results, and maybe feature relevance or local explanations can be especially effective. And these things are also, it's remarkable that's effective in black box models like deep learning or other techniques out of the transparent techniques like logistic regression models, for example, or maybe decision trees or fuzzy logic and other things. So the black box models are not more important in the field of or the area of XAI, we can say that. And another thing is the using the hybrid model for explaining black box model, like using some transparent design methods as an additional modular techniques to explain some parameters inside your black box model. Like, for example, using some additional algorithms to have some heat map for your outputs. By using that, for example, your system, which was predicted that photo is a duck's photo, you can just be using the heat map addition to making some connection with some parameters. So you can be seeing that, yes, our system has just seen the nose, eyes, and ears of and mouth of the dog. So it has just predicted that the photo belongs to a dog. So that's true. We can be trusting that model. That's because it is catching important points of the photo by not looking at the trees, for example, but by looking at the exact face of the dog. And by using heat map, it's a very remarkable way to be explaining how the image-based predictions are done. And of course, by using some additional algorithms like LIME, for example, you can be reaching to somehow visual representation of some outputs of some neurons, for example, inside the CNN. And by just using that, you can be having more idea about details of a bigger picture, and you can be having enough idea about how our system has built the whole picture by using atomic level or pixel level different visualizations, so that you can be have enough idea about if the predictions are trustable by using the image. And also by using the LIME, for example, that's a better sample or an example. I think you can be enabling your system. That's how did you know that photo includes an electric guitar? Electric guitars, the system can say that these pixels are just showing that the photo is that includes an electrical guitar, and I have that probability level to reach to that decision. And also I can say that that's an acoustic guitar because I have catched such pixels from the picture. So that's the line to be used for your deep learning techniques, for example, black box techniques. And the transparency level differs according to techniques, of course. For example, the simplest way to understand that the linear regression. The linear regression just use some mathematical models which are having weights, for example. So you can be having enough idea about for explaining the connection between inputs and outputs by using just weights. That's the explanation. That's very simple, as you can see. But the level of the complexity of your technique is rising towards the deep learning. You should be being careful using the parameters, for example. So because of the limited time, I will just pass that slide, dear friends. But anybody requiring that slide, I can be sending that later to mails or can be sharing with the colleagues from the conference, of course. So I hope my explanations are giving enough idea about essentials of the XAI. I will just give some information about some publications and further things to do and end of my presentation in around 5 to 7 minutes. For example, you can have some idea about some recent publications from Nature journals. like that, for example, an explainable deep learning algorithm for the detection of acute intracranial hemorrhage from small data sets, it says. It's just use heat map based explanation interface, so it explains why it has reached to somehow some detection of clinical results. And by just looking at that, doctors can say that yes, I'm looking at such regions of the the image taken from the brain. So the system is doing the same thing. So it's a good way to be providing a trustable solution. So the heat map is used in that publication. In another sample, the publication from this year, it's from Nature Communications. As you can see, there is the layer-wise relevance propagation algorithm, which is used inside the neural network model. It's just an algorithm, addition algorithm, which decomposes the problem of explaining a complex multi-layer neural network model into simpler sub-functions that are easier to analyze and explain by using some weight values and some many of the parameters. That propagation just gives you some simpler parameters so that you can be explaining the connection between outputs and the inputs. By using that, the authors of that publication has just reached to somehow that visualization in order to explain which input of the neural network has more importance in the decision at the final. You can see the level of the effects of each of inputs for different results at the final. And in another sample publication from +1 from this year, you can see a virtual operative assistant, which includes an XAI for simulation-based training in surgery and medicine. Of course, I'm giving some samples from medical and medicine, but because there are many different samples and more majority of the XAI works for now coming from that field, but you can be searching over the Scholar, Google Scholar or other Web of Science or other environment to see different fields are also using XAI, but the majority of the efforts are coming from medical for now. We will see in the next period, but that somehow includes both education side and the medicine and surgery, because it's just use some machine learning algorithm, and by just using some model selection layer, it's just use some individual metric scoring, which means the evaluation of each of students, which use the simulation for having some surgery and medicine training and receiving some real-time examinations, for example. And by using some parameters coming from the model, the system just say that, yes, you are skilled or you are novice because blah, blah, because your safety assessment is at that level, because your instrument motion assessment is at that level, because I'm saying you are skilled or you have that point, because I'm saying that these assessments are belonging to you, and that's the explanation way. And when we talk about further things to do, what you can be doing regarding the XAI, for example, you can be targeting the user characteristics. You can be researching on target users' characteristics, because the XAI needs more consideration for the human-computer interaction, as I've said before. Of course, the way of the data is very important for both AI and the XAI. And of course, which techniques to combine for explainability is another open problem. And the target problem is also important. Performance problem, optimization problem, user experience are also very important. Transparency level is very important. As you can see, there is the transparent techniques and also black box techniques. And also there is the ethical issues safety level, because that's the XAI means the providing the safety level of the intelligence system. So that can be belonging not only safety, but also to the ethics side. And of course, you can be researching about software and hardware combination in order to be reaching to somehow some more advanced forms of the explainable IoT systems, for example. And also the problems in target fields will be shaping the way of the XAI, and also social impacts are another open problems to be researching on. And for especially my colleagues and for especially our student friends, I can say is that by combining both AI and XAI, I can suggest that be careful about learning philosophy of AI, and it's essential, not technical things, but the philosophy on the background, and learn algorithmic details of AI techniques and write codes manually first, not diving into the libraries directly, because there are many libraries for now. After writing some codes manually, you will be catching the exact logic on the background. So you are free to use library after that, because you will be maybe dealing with deadlines in the private sector, or you will be requiring more speed of the problem solution, not by discovering the America again, for example. So writing codes first manually is the first step, and after that you can be using libraries, of course. And also learning about interpretable techniques is important. Learning about hybrid models of AI is important, because its AI seems to be including the need for hybrid models somehow. And also learning about data science statistics is always important for AI, and of course the XAI. And XAI includes the analysis of somehow mathematical and logical background of the techniques. So learning about statistics, data science, and mathematics and logics are very important at this step. And joining to events, training, or online courses, or keynote speech like I am doing for now, are very important for gaining your knowledge, improving your knowledge and skills. And reading about AI and XAI, considering the concept of XAI, is very important. Read not only from news blogs or videos or newsletters, but also read from scientific publications, of course. And I also suggest you to follow famous scientists to have more idea about what is going on and what tends to be going on in the future. Yes, thank you very much for listening to me. I hope I have not talked in too much speed, because I just try to be using the time more in a more optimized way, because it seems that we are all past the 1 hour time period for now. Sorry for that, and your questions are all welcome, dear friends. I'm just stopping the share of the screen, so I will be able to see the messaging panel of the window. So your questions are all welcome.
Suryakiran sir? Suryakiran sir?
Yes, sir. Thank you for your presentation, sir. Let me read the question and answer questions in the chat. The first question is like, can we use concept learning in explainable AI?
Can we use? Can you
Can
repeat?
you can we use concept-based learning in explainable AI?
Yes, conceptual learning can be a key point, but you will be requiring more careful analyzing the concepts and conceptual view. So you can be using that, but at the end, you may be reaching always to the parameters of the techniques you are using. So after passing from the conceptual analysis, you should be having a careful connection between the conception and analyze and the parameters of the model you are using. So that can be a way. Yes.
Yeah. The second question is like, what kind of parameters do we need to add along with the inputs to neural networks in XAI?
In XAI, in neural networks. You should be using, for example, Lime, or as I just said inside my presentation, some additional things, different back propagation algorithms, which are just designed for dealing with some parameters. By using such parameters, you just reach to somehow some new mathematical models or functions which are using known parameters of your neural network to reach some exponential level. It's just somehow, how can I give a sample? Just like using additional techniques to decrease the level of your data, for example, dimension level of your data. By using additional some algorithms like LIME or other things, other algorithms, you are just reaching to some new kinds of outputs, not only output of your neural network, but also additional values which are explaining, for example, the importance level of the input of your neural network. So by using such integrations, I mean, you can be just make your neural network explainable or interpretable, I can say. Yes.
There is another question, sir. Like, do we need to provide the context along with the data?
For making the XAI, I understand. Yes, you probably need to fit your system or your intelligence system to be fit with the data, with the concepts, because the explanation side for the user is important. So the ensuring the connection between concepts and the way of the data or the view of the data should be made by using that feed to your system. Yes. There's also another question: which one is effective, AI or XAI? I can see from the message panel, so I can also answer that in a fast manner, dear professor. The XAI is a new concept which is included under the field of AI. So that question is just not give enough idea about the way of the answer, but I can say that the XAI is a subfield of the AI for now. And by thinking about the trusting level for your system, we can say that the use of the XAI is more effective by not by using only traditional AI. I can answer like that. I hope the answer is okay for Siet. Yes. Yes. Any additional question?
Sir, Utko sir, thank you so much. It's a wonderful presentation, sir.
You are welcome, dear professor. I'm just providing my email from the messaging sites. I
Sure,
hope
sir.
it's received by everybody. So any other additional questions are all welcome, dear friends, dear listeners. So speech on your side, dear professor. Thank you very much.
Thank you so much, sir. It's indeed a great presentation.
Thank you very much.
Thank you, sir. Thank you very much.
Thank you so much, sir.
Thank you very much. Congratulations for your event, for realizing such a valuable event as my final words. And I'm looking forward for having more such keynote speeches, for informing our dear friends, dear colleagues coming from different regions of the world more in the next time period. And I wish all health and nice days, weeks, months, and years ahead. And after eliminating that COVID-19 issue, I hope we will be reaching to a better life, better things, and I wish everybody and healthy days ahead. So all the best for everybody. Thank you very much.
Thank you so much, sir. Thank you.
Yeah. See you again. Bye bye.
Bye. Bye.
Very good morning, sir. Dr. S.K. Ramesh, sir.
Namaskar. Good morning. Good evening to you. How are you?
Namaskar, sir. Namaste, sir.
Good to see you, sir.
Good to see you, sir. If I am not wrong, we met each other in Coimbatore, Kumaraguru College of Technology.
Kumaraguru, correct. For EPICS.
Yes. So sharply at 8:30 we will start, sir.
I'm ready. Do you want me to
Yeah,
share
if
my
you
screen
want to,
now? Or
if you want to just test your screen, you can just share your screen and test it, sir.
I'm not able to share it still, Professor Kola. I think you need to make me a panelist.
Presenter. Okay, sir.
Presenter.
Okay, sir. Surya will do it, sir. Surya Kiran, sir.
1 minute, sir.
Surya-
Sir. Yeah, sir. 1 minute,
Yeah.
sir. I'm doing. Yeah.
Yeah.
Professor Kola, also I noticed, there was no abstract on my talk, but if you want, I can send it to you after my talk.
Sure, sir. Thank you very much.
You're welcome. How's the conference going so far? I'm the last speaker, right? So,
Yes, sir. This is the last one, sir. Everything went on fine, sir. Right on time. All papers were presented. Everything completed smoothly.
can you see my screen, sir?
Not yet, sir. It is still, yeah. Now I am seeing, sir.
I'll put it in, excuse me. I'll put it in presentation mode. How about now?
Just 2 minutes introduction will be there, sir. Your introduction will be there.
Okay. So
At
you need to
8:30.
stop. You want
Yeah,
me to
after
stop
that you
sharing
can.
right now?
Yeah, you can stop sharing, sir.
Okay. Thank you.
Thank you, sir.
My pleasure, sir. This is my second trip to Andhra Pradesh in the last 48 hours.
That's very nice, sir.
I spoke at IndusCon 2020 at Vizag on Saturday morning.
Geetham University, sir. Which university?
Gayatri Vidya Parishad.
Okay,
GVT.
sir.
So they organized a seminar. I spoke on energy research and sustainability. Then yesterday I was at REC, NIT Surathkal. I gave a talk at Surathkal. It has been a busy weekend. This is my 4th talk in 3 days. So it's okay.
You can also give some inputs to APET accreditation also, sir, at the end of the talk.
No, I'm actually planning to begin with that. So I will start with
Okay, sir.
Yeah.
Thank you, sir.
My pleasure. So please just remember to make me a panelist.
Yes, sir. Sure, sir. Sure, sir. Surya Kiran, sir. Let me introduce, sir, so that I can give more time to sir for our interaction, actually. Can you please share that? Yeah. 8:30 sharply, sir will start. 8:30 sharply, sir will start.
Sure. Perfect, sir. Perfect. Yeah.
Is the video coming through okay, Professor Kola? From your
Yes, sir. Everything perfect, sir. Everything perfect.
Very good.
Good evening, everyone. Myself, Dr. Kola Bhanu Prakash, working as professor in Department of Computer Science Engineering in KL University. It's a privilege to welcome Dr. S.K. Ramesh, sir, Professor, Electrical and Computer Engineering at California State University, Northridge, and Director of AMS Square, program supported by US Department of Education. This collaborative program has been recognized nationally and internationally for its contributions to mentor, support, and enhance the graduation of underrepresented minorities in engineering and computer science. It was recognized as the Baccalaureate Program of the Year by Excellencia in Education in October 2019. Dr. Ramesh has been an active IEEE volunteer for 38 years and has served in several leadership roles on the IEEE Board of Directors 2016-17, IEEE HKN Board of Governors 2012-17, ABET Board of Directors 2013-15, and 2019 to present as Director of Engineering Area Delegation of ABET, representing 32 member societies, including IEEE in accrediting engineering programs worldwide, and as IEEE's representative on the ABET Board of Delegates 2015 to 2019. In November 2019, he was appointed to the 2020 IEEE Fellows Committee. Recent positions include service on the 2018 IEEE Fellows Committee, the 2017-18 IEEE Strategic Planning Committee, and as 2016-17 Vice President of Educational Activities and Chair of Educational Activities Board, and 2016 President of IEEE HKN, the Electrical Engineering Honor Society. At present, he is also contesting IEEE elections as presidential candidate. He was nominated by the Board of Directors. Dr. Ramesh has served as two of the largest campuses in California State University system for 33 years as a dean. He worked as a dean, department chair, and faculty member. Dr. Ramesh's professional interests are in fiber optic communications, and he was elevated as Fellow of IEEE in 2015 and recognized for his contributions to entrepreneurship in engineering education. Please utilize his opportunity. He's having millions of dollars grant under his belt. So he's a renowned professor all around the world. So please make this session a very useful one. Interact, and if you have any doubts, any questions, you can post it in Q&A. So 45 minutes, sir will be giving the presentation, and we will be having a 10 minutes question and answer session. Okay, if you have any queries regarding ABET accreditation also, you can ask him. Okay, sir, it's all yours, sir, now. Thank you very much, sir.
A very warm good evening to all of you in KL University in Vijayawada. Professor Kola Bhanuprakash, thank you very much for that gracious introduction, sir. It is my great pleasure to come to you live from Los Angeles, where it's Monday morning. It is October, but even though it is October, it has been a very warm weekend. The temperatures were close to 100 degrees. And part of the reason, as you all understand undoubtedly, is climate change. And that speaks really to the conference that all of you are having, ICSDA 2020, which is the importance of data science in our lives. So I put together a few slides to share my thoughts with you. And I've titled my remarks, Engineering the Future in the Post-COVID Era, and how data science, I believe, really plays a very critical part in the envisioned future that we have coming ahead. So as Professor Kola mentioned, I'll spend about maybe 40 minutes or so sharing my thoughts with you. Then I'd really like to hear from you on questions that you might have or suggestions that you might have, because truly I believe that the best ideas come from all of you in the audience who are working in these fields day to day. So I'm going to begin sharing my screen. So just give me 1 second while I bring up my presentation. I hope everybody can see my screen.
Yes, sir. Yes, sir.
Thank you very much. So as I said, my title is Engineering the Future in the Post-COVID Era. The gentleman who's standing in the middle of that picture next to me needs no introduction to all of you. It is our esteemed president, the late Dr. APJ Abdul Kalam. This picture was taken in 2009 at Caltech when Dr. Kalam was visiting the United States to receive the Von Karman Award, which is the highest award in aerospace at that time. And it was remarkable to me to be able to stand next to the leader of the largest republic in the world and to have a conversation just as if he was a professor of mine, just as if he was a friend of mine from many years ago. So Dr. Kalam is known as the people's president. And truly, ladies and gentlemen, if you had the opportunity to speak to Dr. Kalam, you would have experienced the same thing that I did that day. But the reason why I share that to you is by way of inspiration for the remarks that I'm going to make today about the engineering the future. So when you think about what has happened in the last 5 or 6 months with Corona and COVID-19, a few months ago, the IEEE Humanitarian Technologies Group in the UK contacted me, and they wanted me to give a talk on the future of engineering because they felt like things were changing so rapidly. Professor Ramesh, can you give a talk on the future of engineering? I thought about it for a little bit, and I said, no, it's not really the future of engineering, but in fact, it is engineering the future, because we are all part of this future, and engineering is going to play a very critical role in that future that we see before us. So with those remarks, let me go on to this next slide. So when I met Dr. Kalam, this was in October of 2009, literally about 11 years ago to the day, I think it was October 7th that he was there. I'm from Chennai originally, and I studied at REC Trichy, where I got my undergraduate degree, graduated in 1981. So I visit Chennai every summer. That summer I happened to be in Chennai, and I usually visit this bookstore called Higginbotham's on Mount Road. I still read paperback books, so I picked up a lot of books, and the two books that I picked up, one of them was Wings of Fire, which happens to be his autobiography, and the other one is called India Vision 2020, where he talks about the future for India as we go forward. Now, I had no idea at that time that I would actually come face to face with him in October of 2019. And so it was a remarkable moment for me. And he personally spoke to me about the challenges that we face in India, and in particular, the conversation that we had probably about 5 or 10 minutes before the actual award ceremony. Said, Ramesh, what can we do about improving the quality of engineering education in India? So this is something that really resonated with my heart. And many of you in this audience, particularly in the state of Andhra Pradesh, know the name Professor Krishna Vedula, right? Professor Vedula has been running this organization called IUCEE, which is the Indo-Universal Collaboration for Engineering Education. So along with Professor Krishna Vedula, along with Sri Narayana Murthy from Infosys, Mr. Deshpande, we came together, and I began to support that movement to improve the quality of engineering education in India. So that was one of the first occasions that I actually met Professor Kola Bhanu Prakash when we had a workshop on epics in Tamil Nadu and Kumaraguru College of Technology. But back to Dr. Kalam. So if you read his book, he talks about there are 4 chief areas of development, and he says people, economy, strategic strength, and infrastructure. And he goes on to say that technology is the answer, but it's not just unmitigated technology. He says that the role of technology will not only be to provide sophisticated machinery, but also to provide materials of basic utility value to the common man at an affordable price. So then, sustainability is important. We also need to eliminate waste, and we also need to mitigate environmental pollution. The last line is very important for me. Technology should not only be for the classes, but for the masses. So in other words, it needs to be affordable, it needs to be accessible. So data science plays a very, very important part in realizing the vision that President Kalam has for India and indeed for the entire planet. And he says sight is what lies right in front of us, but vision is what lies ahead, right? So that's one moment in time in history that I'll always remember from hearing from the leader of our country. And then this is the 5th of October. We just celebrated the 151st birth centenary of the father of our nation, Mahatma Gandhi. And if you remember, Mahatma Gandhi very famously said, be the change you wish to see in this world. The only thing is the change is happening very rapidly. So we need to adapt very quickly to these changing circumstances to make a difference in this world. Now, if that is not enough inspiration, and we just lost him, unfortunately, our late President Sri Pranab Mukherjee said in a conference honoring the birth centenary of Acharya Satish Chandra Mukherjee. He's a teacher and educationist of the early 20th century. That is a reference. This was a talk that he gave in 2014. But pay close attention to what he said. He said, if we can make the necessary effort by creating teams of inspired teachers, by establishing linkages with the global educational fraternity through the maximum use of information technology, by placing emphasis on research, results will follow. So what President Mukherjee was talking about at that time was how can we improve the quality of education in general, and how can we improve the quality of engineering education, particularly in India. Now, data science, the theme of this conference, ICSDA, is very integral to what we are talking about. In other words, if you look at the pace at which data is growing, there is an estimate that the amount of data is doubling around the world every 2 years. Everything from climate change to healthcare to transportation, communications, there is tremendous amount of data that is growing. So we need to not only be able to analyze this data, we need to be able to make decisions based on this data, intelligent decisions based on this data. Professor Kola mentioned my role in the ABET Board of Directors. I currently serve as the Director of the Engineering Area Delegation. ABET, as you know, has 4 large areas: engineering, technology, computing, applied and natural science. The computing delegation of ABET on July 26th of 2020, just about a month back, has published criteria for data science and similarly named programs. So you can actually go to the ABET website, abet.org, review the criteria, and provide your feedback. So by September of 2021, we want to collect feedback from institutions, from students, from industry on how we can go about accrediting programs in data science. So KL University, you're way ahead of the curve by organizing this conference right now. So what are some of the things that we're interested in? We're interested in data acquisition, we're interested in data management, we're interested in data preparation, integration, data analysis, model development and deployment, visualization. At the same time, we need to be very concerned about data privacy, data governance, data stewardship, statistical methods become very important, computational data structures, algorithms, programming languages, all of these play a very important part in data science going forward. So I'm hoping that the papers that you all shared during the last couple of days address these topics. And specific to the case of accreditation, if you go to the ABET website, abet.org, just type in data science and it'll come up with the relevant link for you where you can provide your feedback. Every person in this audience can provide feedback on where you wish to see data science going. And I hope we'll have a conversation about this towards the end. So back to my topic. So my topic today is how the landscape has changed so quickly and so dramatically. Then I want to talk about the role of innovation. I'm an IEEE member, as you heard. I've been a member for 38 years. So I want to talk about IEEE's role, and particularly right now, because all of us under lockdown, we are working virtually, we're working remotely. What are some of the resources available from IEEE? And then one of the things that I really pride myself about IEEE is the humanitarian role that IEEE plays, advancing technology for humanity. That's our mission. So I want to show you how you can engage through IEEE's humanitarian activities, and then a few closing thoughts putting it all together. So that's the plan for the next 30 minutes or so, okay? So rapidly changing landscape, what do I mean by that? So as you know, I teach in the California State University system. That's the largest public university system in the United States. We have about 500,000 students, about 50 to 60,000 faculty and staff spread over 23 campuses in California. So if you came to my campus and you came there on, say, the 5th of March, 2020, just about 6 or 7 months ago, you would have probably seen something like this. You would have seen students on the lawn with their laptops open, their smartphones open. Yes, some of them are probably watching YouTube or listening to music videos and so on, but some of them are actually connecting to classes. They're learning information, they're connecting to the labs, they're doing their work, they're interacting, right? So we're socially connected, interconnected, and we're very close to one another. Then literally in the space of 1 week, we went from this kind of a scenario. Now, I'm not suggesting that this is going to happen, but this is just a depiction of what the world has become today. So if you look today on the same lawn, you can see the same students, but they're nowhere close to each other, right? We are still more socially connected than we've ever been before, because everything we do, think about banking, think about lessons, think about work, all of that is happening on the internet through the technologies that we are enabling as engineers, as entrepreneurs, and as scientists. So all of this happened because of the small microbe, right? The coronavirus that came into our life. And we're still searching for a cure. We're trying to find out how we can defeat this. But in the meantime, the best way to keep humanity safe, to keep us all healthy, is to have social distancing. So this is the reality that we face today. This is one of the reasons why I'm not in person in front of you in Vijayawada giving this conference presentation, but in fact talking from Los Angeles. So given this changing landscape, what is the role of innovation, right? And the grand challenges. So one publication I want to share with you is from the National Academy of Engineering. So if you go to the NAE website, nae.org, you can actually download this book. It's called Changing the Conversation. The book was actually written in 2008, and the circumstances were very different at that time. So in the United States at that time, we were thinking about how can we introduce more students to STEM disciplines? How can we introduce more students to engineering and computer disciplines? So the NAE came up with this publication talking about the role of innovation. So it says, no profession unleashes the spirit of innovation like engineering. And from research to real-world applications, engineers are constantly discovering how to improve our lives by creating bold new solutions that connect science to life in unexpected forward-thinking ways. Few professions have turned so many ideas into so many realities, and few have such a direct and positive impact on people's everyday lives. We are counting on engineers and their imaginations to help us meet the needs of the 21st century. Why is this important right now? Think about the world we live in today. Think about the world where we are completely under lockdown. We're still trying to do business as usual. Few professions have such a direct and positive impact on people's lives. So the work we're doing in data science, the work we're doing in computing, the work we're doing in engineering is incredibly important to engineering the future. This is why we're counting on you, the audience, the researchers, the scholars, the students, and the entire community, and your imaginations to help us meet the needs of the 21st century going forward. I'm sure the National Academy did not think that this was going to happen, but here we are. And indeed, I believe IEEE's mission speaks very much to the times in which we live and how we can move forward. So the grand challenges, we all know about this, right? We know that energy is in short supply, fossil fuels are limited. As a matter of fact, this is my second visit to Andhra Pradesh in the last 48 hours, virtually, of course. I was at Visakhapatnam on Saturday morning, speaking at IndusCon 2020 on sustainable development, the decade ahead. So I spoke about energy research and sustainability in the IEEE conference. Here I am on Monday night. I'm back in Vijayawada. Now imagine if I was doing this in real time, I'd have probably been flying from Chennai to Visag and going back and flying back to Vijayawada, so on and so forth. But think about the impact we've had on the environment. Think about the impact on climate change. Here in California, where I live, even though it's October, I told you that the temperature is almost 100 degrees, and we have tremendous damage from the forest fires. Sustainability is very important. The other critical challenge we face is with food and water. We need to provide nutritious food for populations around the world. We also need to provide clean water, right? Because clean water is at the heart of healthcare. Because with clean water, we can eliminate a lot of diseases. Healthcare has risen to the top. Why has healthcare risen to the top? Because of COVID-19, right? Everybody's racing right now to find that vaccine around the world. You have high-performance computing scientists looking at trillions of combinations, 10 raised to 40 combinations of possible antiviral drugs. You have doctors, you have epidemiologists, all coming together saying, how can we figure out a way to find a vaccine that is affordable, that is accessible, that can be deployed worldwide? Think about the population of the world. We have 8 billion people. If this disease is allowed to go unchecked, it can cause much more damage. It's already caused tremendous damage. Every life lost is a life that we cannot afford to lose anymore. So healthcare has become very, very important. Transportation. I live in Los Angeles. So sometimes I would have meetings in downtown, which is only about 20 miles away. And people would say the meeting is at 8 o'clock. I literally have to leave my house at 5 in the morning to make it those 20 miles because that's how much traffic we have. So smart transportation, smart grid, etc. But the key, ladies and gentlemen, to all of these challenges is education. Think also about what I said at the beginning about data, how rapidly data is multiplying around the world. In other words, the amount of data in the world is doubling every 2 years. So we live in a world that is very complex, that is very uncertain, that is very ambiguous, and that is rapidly changing. And we need to move forward, in the words of Tom Friedman, with speed, with scope, and with scale. So it's really important, no matter what discipline you study, that you become intelligent. You become intelligent, not in a smart, in a negative way, but you become intelligent about how data is collected, how data is managed, and how data can be used to make the quality of life better for all of us. Okay, so a few publications here. I'll very quickly tell you about these. So The World is Flat is a publication that Tom Friedman came up with, where he talked about how through the internet we have all these connections. You could be in Vijayawada, I can be in Los Angeles, wherever you are, you're connected, you're sharing information. And he was talking about the growth of the internet. This is almost 15 years ago, and how globalization was leading to economic development. Then a few years later, Tom published his book called Hot, Flat, and Crowded, because by now it became apparent that as we were jumping on planes, trains, and automobiles and traveling all over the world, we were having a tremendous impact on the environment, pollution, congestion, etc. So what can we do to eliminate that? So he talked about we need to be better stewards of the environment, because it's not just about us, it's about our children, our grandchildren, and the future. Now, the books in the middle, Educating the Engineer of 2020, Engineer of 2020, in case you're wondering why I'm showing you those right now, because 2020 is almost over, and most people will probably say this is the year we want to forget. But these books were written about a decade ago when we were talking about the need to educate engineers in such a way that they're not only good problem solvers, they're able to work in teams, they're able to communicate well, but most importantly, they're able to be inclusive, collaborative, they're able to understand, they're accountable, they're resilient, they're ethical, they're able to understand different cultures, different languages. You see, it's all well and good to say we need to innovate to have economic development. When things are plentiful, when everybody is healthy, when you have clean water, when you have food, all of these things are great. It's very easy to say we can innovate. Right now, humanity is facing the most adversity that it's ever faced. So what we need right now in the words of Gandhi, is resilience. We need to bounce back. Be the change you wish to see in this world, right? Do your duty, be the change you wish to see in this world. What we're asking about is innovating in the face of adversity. That to me is the definition of resilience. That to me is the definition of bouncing back. Right? So with these thoughts for inspiration, where do we begin, right? I say engineering the future. Where is that future? Where do we begin? Well, lockdowns and working from home have slowed down the spread of the virus as long as we're patient. You've seen what has happened in different parts of the world when people get impatient and they start moving around, and then immediately you see the outbreak, right? The infections start to climb. And then governments and public policy experts come in, public health experts come in and say, no, we need to slow this down, so you go back in. In my state in California, my university is completely virtual, 100% virtual since March 12th. This semester, as well as spring 2021. The earliest we're thinking of going back to face-to-face is in August of 2021. So you ask Professor Ramesh, how are you teaching engineering? How are you teaching computer science? We are teaching all of it virtually because we've made arrangements to deliver our labs virtually. We made arrangements to deliver our lectures virtually. We're using synchronous modes, asynchronous modes, we're using computing. But that is not enough, right? We need to provide access. What if somebody doesn't have access to electricity? Without electricity, you don't have access to the internet. So all of these questions need to be answered, right? At the same time, we are spending enormous amounts of time. I'm spending probably 10 to 15 hours a day since March in meetings and conferences and webinars, constantly meeting with people. Now, this places an enormous strain on your mind because you need to be able to think clearly in order to be able to do the work we do. So it's very important for all of us to put things in balance and start understanding the impact that we're having on humanity, because that is the only way forward. So think about the businesses, think about the areas that are particularly at the top of the news. If you take up any paper, Times of India, any newspaper, wherever you take in the world, they're talking about testing. We need more tests. We need to trace people who've been infected. We need to control infection. Think again about this conference, ICSDA, data, right? Because testing, tracing, control goes back to artificial intelligence, goes back to machine learning, goes back to Internet of Things. All these things that you're talking about are critical to healthcare needs right now. It's also having a large economic impact. Lots of industries, retail industries, transportation industry, look at the airline industry, all of these industries are affected, and yet we are able to operate. You know, those of us who are able to work and get a paycheck, we count ourselves very fortunate because we were educated at a time that we can actually use the skill sets that we have to do something good for humanity. So the question always comes up, how do we rebuild, right? At some point or another, we're going to come up with a vaccine. How do we rebuild? What do we rebuild, right? I've heard a lot of people say, how can we get back to the way we used to be? One thought I'd like to put in your mind is that going back is not the way forward. Back is not the way forward. We really need to be thinking about this as an opportunity to wipe the slate clean. How many times as a professor have you walked into the classroom and told your students, imagine, right? And you give them some hypothetical scenario and ask them to solve a problem which is open-ended with a lot of different constraints. So somebody could have told you, imagine that the whole world came to a stop in March of 2020. Imagine that happened, and how are you going to deliver your products and services? And somebody would said, yeah, that's a bad movie, but that's never going to happen. Well, guess what? It happened. Here we are, right? This is what we need to change. So what we can do right now is to, rather than think about going back to the way things are, we can really wipe the slate clean and rebuild what we truly need, right? So left to ourselves, I don't think humanity would have ever confronted this question. This would have been the subject in research conferences. Papers would be written about it, highly cited papers in journals and publications, but nobody would have really gone on and said, how can we rebuild what we need, an innovation-based economy? So what are some signposts on the horizon? I've already talked about the challenges. Quality of life is very important. Even before COVID-19, the rate of unemployment in the United States was about 5%. Now, to put that in perspective, we have about 160 million jobs in the United States. With COVID-19, that number is raised to about 20%. Around the world, there's about 800 million jobs. Imagine that 20% of those people are unemployed. 20% of 800 million, that's a large number. If those people are not earning a paycheck, how are they going to be able to take care of their families? How are they going to be able to earn a livelihood? How are they going to be able to support humanity? So what are the opportunities? We know the challenges. As I often tell my students, let's stop admiring the problem. Let's roll up our sleeves and figure out what we can do. What are the opportunities? I clearly believe that sustainable technologies are the key to our future. In other words, this has brought the world to a halt, but still we are connected. So how do we sustainably, with renewable energy sources, with clean energy, provide transportation, provide healthcare, provide clean water, provide food, provide all of these things that humanity needs at this time? So the technologies that I mentioned at the bottom AI, IoT, 5G, ML, these are all key to the future. But independently, none of these technologies mean anything to anybody, right? You can have the smartest computer in the world. You can have the fastest, the latest iPhone in the world. But if you don't have power, if you don't have access to the internet, it is not going to do you any good. So we really have to be thinking sustainably on how we're going to help people where they live, where they work. Okay? So how do we adapt for success? How do we future-proof this world? I go back to our core values, and I'll tell you why in a minute, how this is so closely connected with IEEE. And core values to me begins with trust. And trust means we need to be transparent, we need to be open, we need to be respecting one another's views. Look around the world today, close your eyes and look around the world today. More people are collaborating because we have this common enemy. Humanity is looking at COVID-19, the coronavirus, saying, what can we do collectively? So no longer does it matter you're a citizen of India, you're a citizen of the world, right? The community is humanity, and you're trying to do what you can to make a difference for humanity. The second thing that I see is that this microbe, unseen to the naked eye, has caused so much disruption in the world where we're literally locked down in our homes and we're trying to work. But in a way, it has brought something else into perspective, which is nature is the ultimate balancer. Up until now, in the words of Tom Friedman, hard, flat, and crowded, thanks to globalization, we were causing a lot of damage to the environment. Climate change is very apparent, right? We see hurricanes, we see warm weather, we see cold weather, we see all kinds of damage to the environment, but people go about it saying, well, in my local environment, everything is okay. Now, COVID-19 all of a sudden has put a focus on nature, saying things need to be in balance. And so we need to provide a world that is safe for our children, our grandchildren, and so on. This is a Native American proverb. We do not inherit the earth from our ancestors, we borrow it from our children. This to me is very profound, very, very important for all of us. Third, I see this element of gratefulness. In other words, people are sharing more than I've ever seen before. You think about ventilators, right? The patients who are vulnerable, who are being affected by COVID-19. There's teams